First thing first, we are going to start Cisco SDA, Cisco Software-Defined Access, also known as SD-LAN. Some vendors, they refer to it as the LAN, Software-Defined Local Area Network. Cisco calls it specifically Cisco SD-Access, Software-Defined Access. Some vendors like Extreme Network and all, they call it like SD-WAN. It's quite same. This Cisco SDA solution is specifically it is targeted, it is focused on the campus local area network. We have wired and wireless devices in our campus local area network. So how we are going to manage these wired and wireless devices from a centralized place, from a centralized point. This Cisco SDA solution is primarily targeted for this LAN side of the enterprise network. For the WAN side, we already have SD-WAN. For the data centers, we already have ACIs, ACIE EPIC. For the campus enterprise, for the enterprise network, we have this as the access technology, as the LAN technology, which is targeted to manage the wired and wireless users, wired and wireless devices, like such as access points, WLCs from a centralized point. So let's first discuss about the content that we are going to cover in the SD-Access, and then we will talk about the documentations, the labs and everything, and then we will proceed with the PPTs. First thing first, there is no official certification for the Cisco SDA. Like other exams, like we have CCNA, we have in CCNP, we have many exams such as NRCs, we have like SD-WAN exam, we have enterprise core exam. Unfortunately, for the Cisco SD-Access, there is no dedicated certification exam. There is no dedicated certification exam for this Cisco SDA technology. Not at least yet. Maybe later on they might announce some kind of like dedicated certification exam for the Cisco SDA. But at the moment, there is no such thing. It is primarily covered into two certifications. One is like ENCOR, Enterprise Core, and the second is the CCIE Enterprise Infrastructure Lab exam. So whatever content we are going to cover is going to include everything that is there in the ENCOR, that is there in the CCIE Enterprise Infrastructure Lab exam, from the SDA point of view, from the SD-Access point of view. All the things that they have asked in the ENCOR or the Enterprise Lab exam regarding SDA, all those things will be covered. Plus, we will talk about like additional things such as we will talk about like wireless, we'll talk about like a little bit of the IEs and all. So like we will make sure that this is covered 100%. And additionally, we will talk about like how to add on the WLC, how to add the access point, how to integrate the identity services engine, how can we create the policies for the device administration, how can we create the policies for end user authentication, how can we create those policies. That also we will talk about at the end. But primarily we will focus on the ENCOR and CCIE Enterprise Infrastructure Lab exam. So from the content point of view, we have to look up the curriculum, the content from the ENCOR and CCIE Enterprise Infrastructure Lab exam to know what topics we are going to cover specifically. Apart from that, we will cover some wireless, some IEs, and all the additional topics, other things as well. But first of all, we will focus specifically on the things that they have asked on the ENCOR exam, Enterprise Core exam, and CCIE EI Lab exam. Those two things we are going to first of all. So if you go to the like Cisco, if you go to like Google and just search like ENCOR, you will see the Enterprise Core exam, so implementing Cisco Enterprise Core technologies. Here you have this ENCOR exam. ENCOR version 1.1 was there, but it has now been revised to a new version. Click on the View ENCOR topics. Click on here, and the version 1.2, not 1.1 now. It is version 1.2 is now live. So this is what we are going to focus on. Screen is visible to everyone. Can you guys confirm once? Okay. Okay.
Yes, sir.
Because
I
you
have
can.
one question. I have one question, sir.
Yeah.
Can you change the board color like black to white?
Which one? For what?
I think board color, background color, sir.
For what? For the screen?
Yes, sir, yes, sir.
It's just
Black
the
to white.
wallpaper. I will have to. Okay, I will see. I will later on when I will open the notepad and explain it there. It's just the wallpaper. I have not like anything. Because you can rejoin once, might be some issue. So the ENCOR exam is now on version 1.2. Earlier it was version 1.1. Now it is on version 1.2. So again, 120 minutes exam, $400 US, focuses on a lot of things. What we are going to cover from here regarding our SDA, regarding our SD access. Of course, like we're not going to cover complete ENCOR things. We are specifically going to see the SD access, SDA related things in the ENCOR exam, and we are going to cover it first. So what topics are there under the ENCOR exam that we have to go through? So take a look at the architecture, the first section, the first unit that we have in our ENCOR exam, which is architecture. So explain different design principles used in enterprise network, 2-tier, 3-tier, fabric, and cloud. So 2-tier, 3-tier generally is covered in the switching part. So in the switching part, it is covered. We will talk about the fabric in our SDA. We have a topic that is create an SDA fabric. So we'll talk about like what is fabric, how to create the SDA fabric in our campus area network, that we will talk about. We're not going to talk about like FHRP, HSRP. We're not going to talk about the SD-WAN. We are going to talk about the SDA. Explain the working principle of the Cisco SDA solution. SDA control plane, what is SDA control plane, what is the SDA data plane, how the traditional campus network differentiates from the SDA network, how the interoperability will be there, how the migration, how can you migrate from the traditional to the SDA and all that thing. Basically, the fundamentals of the SD access, the basic thing we will talk about here. This is regarding SDA that we have to go through. Okay, fine. Then in the virtual, nothing else that is relevant to our SDA classes, nothing else, just this basics of the SDA. Then virtualization. Here we will talk about the Lisp VXLAN, other things such as what is a server, what is server virtualization, those things we don't need to worry about. VRF, GRE is part of the routing, so we don't need to worry about. Here is what we are going to cover in our SDA. In our SDA, we will talk about this technology called Lisp and VXLAN. These protocols called Lisp and VXLAN. By the way, it is just described. It's not like we have to configure it, but we will go through the technicals of the Lisp and VXLAN, how the SD access control plane works on the Lisp, and how the SDA data plane works on the VXLAN. The Lisp fundamentals, the VXLAN fundamental. Note that we will not implement it manually. I am not going to configure the Lisp or VXLAN manually. I will let the Cisco SDA solution, I will let the Cisco DNS Center configure the Lisp and VXLAN automatically. We will talk about the fundamentals, how Lisp operates, how the VXLAN operates, the commands and everything we will go through. What configuration is pushed from the DNS Center regarding Lisp and VXLAN, we will go through that. But I'm not going to, or we are not going to configure the Lisp and VXLAN manually in our enterprise net, right? So we'll talk about the fundamentals, we'll talk about the commands and everything, but we are not going to configure it. This is what we are going to cover. This we will cover in our SDA classes. This part we will go through, we will cover in our SDA classes. Then scroll down to the infrastructure. Nothing that we have to worry about from here. Nothing that we have to cover from here. Nothing that we have to cover from here. Yes, that's fine. So nothing that we have to cover. And this is part of switching. This is part of routing completely. So when you go through the routing classes, when you go to the switching classes, there you cover about these things. But in our SDA, we are not going to cover, like, of course, like we are not going to cover these topics. Go to the next section, that is assurance. Under the assurance, we will talk about this one. We'll talk about this, describe how Cisco Catalyst Center, how Catalyst Center, formerly called DNS Center, is used to apply the network configuration monitoring management using the traditional and AI powered workflows. So this we will cover in our SDA classes. We will talk about the how we can use the DNS Center, Catalyst Center to apply the configurations, monitoring, and all that thing. So assurance, monitoring, configuration, provisioning, this we will cover in our SDA. Then under the security, AAA, we will talk about the AAA. We will talk about the local authentication, user authentication. This we will cover in our SDA. We'll talk about like .1x, 802.1x. We'll talk about Identity Services Engine, IIS. How to integrate the Identity Services Engine IIS with the DNS Center. How can we configure the AAA? How can we configure the end user authentication policies? How can we configure the device administration policies? Those things, basically .1x, radius TACAX, we will cover under in our SDA training. We will talk about it. So this part will be covered. Configure and verify. This part will be covered in our SDA, by the way. We will talk about it. Rest, like access control list, control plane protection, routing, describe the components of the network security design, like not part of our SDA curriculum. There they have talked about the firewalls, next-gen firewalls, IPS, IDS, several products that Cisco offers in their security portfolio. They have talked about that. No need to worry about it. So we'll focus specifically on the .1x. We'll focus specifically on the AAA.1x radius and TACAX in here basically. And then at the end, we will talk about APIs. We'll talk about some application programming interfaces. We will talk about like some APIs, how these REST-based APIs, how can we interact with the DNS center using REST-based API, representational state transfer. How can we interact with the DNS center using some REST-based API? We will use the web browser. We'll use the developer toolkit that is present in the DNS center, Catalyst Center, to build or to do some API calls, some APIs we will run, and we will see what information we can get after running those APIs. How can we get the complete control? How can we get like the control on every aspect of the DNS Center, Catalyst Center using the application programming interface? That we will talk about here as well. Right. So this is the part that will focus from our ENCOR content. Just to confirm once, again, the screen is visible to everyone, right? Can you guys still see the screen? Is it visible now, Ranjit? Can you see it now?
Yes, it is. It's clear.
Okay.
Yeah, Surinder, I'm not able to see the screen.
I'm really not sure. Like you can change the browser once, like it's visible to others now.
Teams link or it is the Zoom link? What is the link you shared?
It starts working after you rejoin. So I was also facing the same issue. It starts working after you join.
It's just like I'm sharing it from the Zoom itself, so it must be visible on the same window. Like there's no other link actually.
If you can share me the Zoom link, I can join the applications.
Yeah, sure. I will copy. I have sent the link in the chat. You can copy it from the chat and join directly from the Zoom for today.
Okay, let me see that.
Right. So this part, it is specifically from ENCOR. This is like specifically from the ENCOR. Like anyone like who is willing to attempt the enterprise lab exam, maybe later on, they want to attempt the ENCOR exam later on, they must be aware of these SDA topics. It's very limited in the ENCOR. To be honest, like if you go to the official book of the ENCOR, you will find like only one or two chapters for this Cisco SDA. In one chapter, they have described like what is SDA, what are the components of the SDA and all. And in the other chapter, they have described a little bit about AAA and all those things. Right. So not a lot of things. Doesn't give us the idea like what practicals and all those things we are going to do here. So this is the part that we will focus on. This is the part that we will cover. This is the part that we will focus on specifically from our ENCOR content point of view, specifically from our enterprise core and core content point of view. But the actual topics that we have, the actual things that we have actually, this is when you go to the CCIE Enterprise Infrastructure Lab exam. When you go to this Enterprise Infrastructure Lab exam, here you will find like a good amount of topics that you must know from your enterprise network point of view, plus the lab point of view as well. Like these are the topics that you must follow, that you must know from the enterprise infrastructure, your enterprise network point of view, and also the lab exam. So specifically when we talk about like the 1.1 lab exam, specifically when we talk about it, here we have a dedicated section. This is software-defined network. There is a dedicated section of it. Here, it focuses on two things, SD-WAN and SDA. It focuses on two things, SD-WAN and SD-Access. First, we have like SD-WAN, SD-Access. Then we have the SD-WAN. We have two things that we have to cover. So if you go through like the SDA topic specifically, these are the SDA specific things that we have here. These are the topics, these are the things that you must know from theory and lab point of view. Overall, this much. These are the topics that we will focus on from the theory and lab point. We will also cover additional things such as wireless, ICE and all that thing. But these are the main things that we will cover from the theory and lab point. First of all, how to build in SDA, how to build the underlying infrastructure so that we can run SDA on the top of it. Underlay, how to build the underlying infrastructure. We have like a few, we have for example few switches in our campus network. We have a few switches, some access layer switches, some distribution switches, some core switches. We have a few switches. We have built our we are running our topology. How can we build the underlying infrastructure to support the Cisco SDA manually? How are we going to build this underlying infrastructure manually? How are we going to use the DNA center, the catalyst center, to build this underlying infrastructure automatically? How to discover all these devices? They are like all of these devices, by the way, at the moment, they are like switches. We can also have like routers. We can also have like wireless devices such as access points. We have other devices such as like WLC. So how are we going to discover the devices? How are we going to manage the devices from a centralized point? What is this extended node, policy extended node, part of the underlying infrastructure? Basically, we will talk about like how to build the underlying infrastructure, how to make the reachability between all these devices with the DNS center, so that like DNS center can manage, so that the DNS center can build the overlay network on the top of it. Greenfield, brownfield, both. Greenfield basically means like we have to set up a branch, a software-defined branch, and as the branch, like from the scratch, we are required to purchase completely like fresh new devices, new switches, new routers, new access points, everything. And we have to build the infrastructure from the scratch. That is going to be the greenfield deployment. And the brownfield deployment, basically, when we have to implement the SDA in the existing infrastructure. What considerations should we take before we plan to migrate from the traditional to the SDA? Both things we will talk about. Manual, automatic, how to discover the devices and all that thing. Basically, how to make your infrastructure ready to implement the SDA, that we will talk about under this underlying infrastructure, right? Underlay. This is specifically going to be the part of underlying infrastructure. Once the reachability is there, once your underlying infrastructure is ready, then how can we build some tunnels? How the DNS center, how the catalyst center will help us in building certain tunnels on the top of this underlying infrastructure, so that we can send and receive the traffic. Tunnels built based on protocols such as Lisp, VXLAN, Cisco TrustSec, BGP, how to implement the multicast, what is layer 2 flooding, how to control it. Basically, the concepts of the overlay will be discussed afterwards. Like once we have built our underlying infrastructure, then how can we build our overlay network on the top of it? That we will talk about in this overlay section of our list, the BGP, VXLAN, Cisco TrustSec. We'll talk about both theory and lab, everything like theory lab, both will be covered in our SDA curriculum. How are we going to build this overlay? How are we going to build basically this fabric? How are we going to build this SDA fabric in one site, single site? How are we going to build the SDA fabric in another site? How are we going to connect it with the help of this thing called transit? Single site campus, multi-site campus, fabric in a box feature. We will talk about what is fabric in a box, where we configure the fabric concept in a single device. In one device, we can implement the fabric concept itself. So in a small to very small deployment, we don't need to have like many switches. We can have just one switch and we can implement the fabric on that single switch itself. That is what we call fabric in a box, which we will talk about in our content later on in quite detail. So how to build a single site campus, multi-site campus, how to connect it with the help of the transit. What are the different types of transits? IP transit, SD-WAN transit, SDA transits. What are the different types of transit? In SDA, we have like Lisp BGP based transit. We have Lisp PubSub based transit. We'll talk about all the different types of transits that we can have to connect multiple fabric sites together. What is this fusion router? What is the role of the fusion router? What is this fusion router? How to configure it? How to configure BGP on it? The route leaking, XYZ things. Basically, we'll connect these two fabric sites with the help of the transit, different types of transit, which will be covered under this handoff section. Layer 3 handoff, layer 2 handoff, we'll talk about both. Whatever things are mentioned in this curriculum will be covered completely. So layer 2 handoff, layer 3 handoff, that we will cover, that we will talk about. Different types of transit we will talk about. So how to connect multiple sites with the help of the transit, that we will cover. How to onboard an end user, how to connect an end user, whether it is a wired user or a wireless user. How to onboard, how to connect, onboarding, host onboarding, end user onboarding, how to authenticate it per port configuration, a remote border, multi-site remote border. If you have multiple, now there is a concept called border node. If you have multiple border nodes, how can you set the priority on those border nodes, how to add the devices in the fabric? Basically, the end user onboarding, the host onboarding process we will talk about at the end. We will talk about the fabric deployment. Under the fabric deployment, we have this host onboarding. And at the very end, we'll talk about segmentation. How can we isolate our corporate users, maybe from the guest user? How can we configure the policies in such a way that inside the corporate users, we have different types of users, such as we have HR, we have finance, we have like IT admins. I do not want all of these are part of the same network. All of these are part of 10.1 network. All of these are part of 10.2 network. Even though all these are part of the same 10.1 network, I don't want them to communicate with each other. Or I want that HR and finance must not be able to communicate, but admin user must be able to communicate with the finance. Admin user must be able to communicate with the HR. That I want the communication must happen. So how can we configure this thing called macro segmentation? Macro segmentation, and how can we configure this thing called micro segmentation? Macro means like segmentation more like at a big level, like corporate, guest, IoT devices, for example. And then within the corporate, HR, finance, admin, IoT like CCTV cameras, sensors, other servers, for example. That is micro segmentation. Even though they are part of the same subnet, but they can't communicate or they can communicate. That is micro segmentation. So this we will cover at the very end. We'll talk about once our fabric is deployed, once the end users are onboarded, then we will talk about this micro segmentation and macro segmentation, which is going to be implemented with the help of identity services engine. These are the main topics that we are going to go through. These are the main things. These are the main topics that we are going to go through. This is theory and lab. Whatever things we have to talk about from the theory point of view, whatever things we have to talk about from the lab point of view, we will cover it. And then additionally, we will talk about things such as wireless, how to onboard the wireless LAN controller, what things we can do from the DNS center once the integration is done between the DNS center and the wireless LAN controller, what things we can do from the DNS center regarding the wireless, how to create the for example, SSIDs, how to configure different types of profiles, wireless profiles, how to instruct the WLC about the authentication, AAA, and all that thing. Once we add the WLC, once we add the wireless LAN controller in the DNS center, how and what things we can manage from the DNS center regarding the wireless, that we will talk about. We'll talk about the AP onboarding. We'll talk about the wireless user onboarding, how to onboard the access point with the WLC, how to onboard the access point in our SDA fabric enabled WLC, fabric enabled access point, that we will talk about. How to onboard a wireless user, for example, how to onboard a wireless user, that we will talk about. It's not going to be much, but wireless also, like how to add on the AP, WLC, the wireless users, how to configure the policies for the wireless users and all that also we will cover as a part of our content. Apart from that, ICE, Identity Services Engine, not the dedicated ICE course I'm talking about. Like we'll talk about ICE integration with the DNS center, and then what things we can do from the ICE, such as like device administration policy, TACACS, end user authentication policy radius, micro segmentation you can do from the ICE and the DNS center. If you want to do the micro segmentation from the DNAC, you can do it from DNAC. If you want to do it from the ICE, you can do it from the ICE. So ICE integration with the DNS center also we will talk about, and then we will create the policies. And this is the whole content that we will go through in our Cisco SD-Access, in our Cisco SDA training. Since there is no official certification for the Cisco SDA as of now, these are the things that we have to focus on specifically from the content point of view. Content of ENCOR, content of CCIE lab exam, plus general things that you might see in your production environment regarding the SDA, like wireless, access point, WLC, ICE. These are the things that we are going. This is the content. This will be like this will take some time. It will take some time, since for many of you it might be a completely new technology. So some of you might already be working on it. So some of you might. For some of you, like it might be a completely like fresh, completely new technology. So it's not like we are going to cover these content like very fast. We are going to we'll go slow. We'll talk about like Lisp, VXLAN. Starting few classes, I believe at least 1 week, Monday to Thursday. At least that much. At least we are going to go through some theory topics first of all. We'll build the base, and then we will move on to the theory and lab both. It will take some time. It will take some time to cover this Cisco SDA training. It's approximately 50 to 55 hours content. It's approximately 50 to 55 hours content that we are going to go through. 50 to 55 hours, 2 hours per day, 4 days a week. So you can calculate the rest. We'll have the classes like Monday to Thursday, 8 to 10. So you can convert the things accordingly. It is approximately 50 to 55 hours based on like, also based on like how many questions you ask, how interactive you want this class to be, what questions we have and all. Might go a little bit above 55 maybe, but generally like from the training perspective, from the training point of view, it's generally 50 to 55 hours training, including the lab, theory and all. It will easily take like 1.5 to 2 months to cover the complete things. So from the content point of view, these are the things that we are going to cover. From the content point of view, if you have like any queries, we can discuss. Not like how we are going to cover it, just like this is the content that we are going to go through. Anything that you want to ask from the content point of view, we can take questions. Then I will tell you like how to.
Yeah. Yes. So you'll be discussed starting from the maglev configuration, right? From the initial configuration.
Yeah. That thing we will talk about, but not from the very first class, not from the very beginning. We will talk about like everything from the scratch, all the way from the installation of the DNS center, all the way to configuring the policies and everything. Some of those things might not be practical. For example, I'm not going to install a DNS center in front of you. It's already deployed, already running. But I will walk you through the wizard, the process of installing the DNS center, installing the image and all that thing. But not from the day one. Maybe like when we reach to a certain level, like maybe after a week, when we start the lab part of our DNS center, Catalyst Center, yes, definitely we'll talk about it.
So then you will explain about the what are the port is contained in the DNS Catalyst Center, and yeah.
Correct. The hardware appliance that we have, the ports that we have in there, what ports is used for what purpose.
What about the migration part of the current DNS center to the Catalyst Center?
No such thing. Both are the same products, Catalyst Center and the DNS Center. Migration, like it's just like you can upgrade from the dashboard itself. Otherwise, you can download the fresh image if it is compatible with your existing DNS Center. It's the same product, just the different name.
Yeah, but both the different OS or same OS?
Same. It's the same. It's same maglev, same.
Existing DNS Center and the current the Catalyst Center.
DNS Center and Catalyst Center are the same thing. DNS Spaces is a different thing.
No, not the DNS Space. By mistake, I came the word. Okay,
so DNA and Catalyst Center, they are the same thing. It's like IMEDITA SD-WAN and Catalyst SD-WAN. It's the same thing, just the name has changed. Just in the graphical user interface, the GUI has changed a little. The installation steps and all that thing remains pretty much the same. We'll walk through the installation process of the Catalyst Center, DNS Center. Migration, if you want, like we'll talk about it, but to be honest, like there's nothing to migrate in that. It's just like you can log into your existing DNS Center deployment. You can check whether it supports the upgraded, the new images, the version 2, version 3. If yes, then just upgrade it from the dashboard itself. I will show you. Otherwise, you can download the fresh image and then boot it up with that image. We'll talk about it.
Thank you.
But yeah, but just to give you a general idea, the Catalyst SD-WAN, IMEDITA SD-WAN, same thing. DNS Center, Catalyst Center, same product, same thing. Just like some new enhancements are there. Here and there, the user interface has changed. But behind the scenes, it's the same. It's the same thing, same hardware, same things. Just the look and feel has changed.
So how we can practice this all in the dCloud?
Yeah, we'll talk about it.
Achievable?
We'll talk about it.
Okay, thank you, sir. Yeah.
Content. This is the content that we are going to cover. From the content point of view, if you have like any queries, we can discuss first. Whatever is mentioned in the ENCOR curriculum, whatever is mentioned in the Enterprise Infrastructure Lab exam curriculum content, it will be covered A to Z. Nothing will be left from here. Plus, we'll talk about the wireless, access point, WLCs, ICE integration, and all those additional things. We'll talk about it. It will be both theory and lab. So
this content, it is very perfect, and all the features are available here.
No, it's again when it comes to like compatibility and all, some specific switches are compatible, which we will cover later on. So not all the vendors or not all the vendors are supported, not at least for the fabric part of the DNA center. We'll definitely talk about it, but we'll focus specifically on the Cisco-based devices, the iOS XE-based devices.
Hello, Surinder. This is Sachin. But are we going to discuss about the migration approach as well, like from legacy to SDA? Like in
parallel deployment, incremental deployment,
Let's say we have
Yes.
two-tier architecture or fabric in a box. So in that case also, which would be what would be the best approach for those architecture? That thing also.
We can cover it. There is a dedicated guide for it. Actually, there is a migration guide available from Cisco itself. We can go through it to know how to do the migration from the traditional to the SDA. There are a few considerations that we have to take. Definitely, we can spend at least one class in that. Definitely, we can do that. Now, in order to cover these things, like since there is no official certification exam for the Cisco SDA, unfortunately, there is no proper guide. There is no proper the book for the SDA as well. There is a book. There is one book. There are a few things that you can refer to. If you want to know, if you want to learn more theory, then there are a few things actually. First of all, ENCOR, the official book of the ENCOR Enterprise Core. That book you can refer to. If I show you that official book, just a moment. In that book, there are a few chapters. There are like one or two chapters. Let me quickly show you the ENCOR book, Enterprise Core. Here is the ENCOR book 35401. If you go to the sample content and here you go through the architecture, scroll down all the way. Here in the chapter number 16, which is overlay tunnels, they have talked about the Lisp VXLAN, page number 495 to 504, right? So a few pages for the Lisp and VXLAN, not like practical. It's not like you have to practically do it. So if you want to know, we will talk about the Lisp and VXLAN in our classes, but if you want to know more about it from the theory perspective, this is what you can go through, Lisp and VXLAN. This is how much you have to know from the exam, from the content point of view. This is from where you can cover the Lisp and VXLAN related topics. Then if you scroll down, there is our architecture. In the network architecture, you have 640. And by the way, it's introduction, but it's Cisco SDA, and then one chapter for the Cisco SDA. Here is one chapter for the Cisco SDA. Here is the one chapter for the Cisco SDA. A few pages that you can go through to know about Cisco Software-Defined Access. Of course, it's not enough, but it is what it is. From the ENCOR exam point of view, this is the chapter number 23. In the chapter number 23, you can cover a little bit about the SDA. In the chapter number 22, you can cover a little bit about the SDA. And in the above chapter, like this one, the overlay tunnels, the chapter called overlay tunnels, you can go through the Lisp and VXLAN. So very limited content that you have to go through, very limited content that you will get from the document point of view in our ENCOR content. So you can cover a few things from there. Unfortunately, there is no book for the CCIE Enterprise Infrastructure. There is no book for that. So nothing that you can cover, about this from the book. Actually, there is one dedicated book for the SDA. It's not an official certification guide because there is no official certification for the Cisco SDA, but there is a Cisco SDA official book. There's an official book published from Cisco itself. This is one official book of the Cisco SDA. It came like a long time. Like it has been like, I believe, 5-6 years since this book is published. In fact, this book came before the SD-WAN book, so the Cisco SDA. And if you go through the sample content, basically the index of the book, this is what you can go through. Chapter 1, chapter 2, there are a few chapters in this book, like 8-9 chapters that you can go through to know more and more about the Cisco SDA. In past 5-6 years, the Cisco SDA solution, the DNS Center solution has evolved a lot. So there are a lot of things that they have not covered in this official book. But still, like from the beginner's point of view, from the getting started point of view, this book is quite good. You can go through this documentation, this book, where you will know like why we need SDA, how the SDA solution was developed, what are the components of the SDA, the ICE deployment, the macro segmentation, basically everything that we have covered, everything that we have to cover, that we have to know from the SDA point of view, can be covered from this book. This is the official book that you can go through to know more and more about the SDA from the theory point of view. They have included a few labs, but it's more like, again, you will get more and more information about the SDA solution from the theory point of view in this official. This book could have been like 4 or 5 chapters only, to be honest. Like, I will be very honest, like this book could have been like only 4 or 5 chapters. In a few, like first 2 or 3 chapters, they have just talked about like what are the problems in the current campus local area network, how to solve it, how the DNS center was created, what are the options available in the DNS center. So they have stressed like this book like quite a lot, but still like it's very much relevant from our current deployment point of view as well. It's very good. Like I will definitely ask you to go through this book if you want to know more about the SDA. But if you want like some short notes kind of things, you don't want to go through like all that, complete like book. There are some other small books as well that some general like documentations, for example, you can refer. Like for example, design guide. There are some general documentations that you can refer to from the Cisco website itself as you are going to deploy the SDA solution in your maybe production environment. So there are simple like guides that you can refer to from the Cisco official portal itself, and there are some other small books that are written by some not Cisco but from some other authors. Some engineers, basically some 2, 3 engineers, 4 engineers, they wrote some documentation regarding the SDA, a very concise, very precise, very short notes kind of thing. So that also you can go. Basically, from the documents point of view, you can go to the official books, or you can also refer to the official documentations, or you can refer to some other third-party books that some engineers, some network engineers, they have written based on their production experience. Migration guide, deployment guide, basically design guide. Different guides are available officially from the portal, Cisco portal, that you can read, that you can go through when you have to deploy the SDA in your production environment. You can refer to these documents. You can refer to these documents to know more and more about the Cisco SDA solution from the theory point of view. These are quite good books that you can refer to. Certain things you must already know before you continue with your SDA classes. Certain things you must already know. Let me tell you what are the prerequisites for this course. Of course, it's not a beginner level course, of course. So there are certain things that you must already know before you start the Cisco SDA training. What you must know is what is LAN. What you must know what is like switching. You must know what is a switch. You must know what is a layer 2 switch, what is a layer 3 switch, what is the difference between the layer 2 switch, what is the difference between the L2 and L3 switch, what is this SVIE, what is this L3 interfaces, what is this L2 interfaces. All these things are part of the switching. But I'm trying to say that you must have the knowledge of switching. Switching, there is a dedicated content of the switching, by the way. So since it's a LAN solution, you must have the knowledge of like switching. No, I'm not saying that you must have like very good knowledge of the switching, but you must have at least some knowledge of switching, like what is this 2-tier design, what is this 3-tier design, access distribution, like access distribution and core, then access and core distribution. You must have some basic idea about the switching fundamental. What is VLAN, what is trunks, what is like switch port, no switch port command, what is SVIE. Those general things you must know. Switching you must have some idea about. Switching you have to know, switching you must know before you start with the SDA. In fact, you must know about the routing as well. We're not going to use routing that much, but you must at least know what is OSPF, what is EIGRP, what is BGP, how the BGP neighborship, how BGP neighborship works, how can we advertise a network in BGP, basics of the BGP. I'm not saying that you have to know whole like path attributes and all that thing, if you have already gone through the routing classes, then you might remember that we have gone through like at least 22 classes for the BGP. Not all that, but you must know what is BGP, what is iBGP, what is eBGP, how the BGP neighborship is formed, how we can advertise the network in BGP. What is this thing called redistribution? Why these things are required? Because later on there will come a topic called handoff, and here we will use this border gateway protocol. There will come a topic called manual underlay. There you can use the protocols such as OSPF, EIGRP to make the reachability in your underlying infrastructure. So you will have to have some like at least some intermediate level of knowledge some basic to intermediate level of knowledge of the routing as well. I'm not saying that you go through all the BGP attributes or all the OSPF packets, states, and all that thing. No, not at all. But at least you have to have the understanding of the what is OSPF, what is EIGRP, what is BGP, how the neighborship is created, what is this neighbor command in BGP, what is this network command in BGP, what is this redistribution. Some basic things we have to know regarding the route. Otherwise, this topic, otherwise the handoff topic will definitely make no sense to you. Like if you not enough understanding of the protocols such as BGP, OSPF, EIGRP, it will be hard for you to understand that handoff thing, that underlay concept. It is very basic, but at least you'll have to know. VRF, virtual routing and forwarding. VRF, we have to have some idea what is VRF. Why do we need VRF? How can we achieve the segmentation with the help of the VRF? That thing we'll talk about. What is VRF? How to create the VRF? Some basic idea about the VRF you also need to. VRF has the main important concepts. The VRF have this thing called RV. What is this route distinguisher? What is this route target? Route target import, route target export. We'll talk about it briefly, but it is mainly part of routing, by the way. So you have to have some understanding of the VRF. We'll talk about what is RD, what is RT, import, export, and all that thing. But it will be a good idea if you know about the VRF, RD, RT, at least a little bit, so that you can ask the question, so that you can get the concepts of the handoff. When we talk about the handoff, we will use this VRF, RD, RT concept, import, export, and all that thing. So you have to have some understanding of the VRF as well. Apart from that, .1x okay, ICE okay. Even if you don't have any knowledge, it's fine, all good. Wireless. When we, for example, later on at the very end of our curriculum, when we will talk about like the wireless, we have this access point, we have the wireless LAN controller. What is the access point? What is WLC? How they communicate with each other? What are the different modes in which access point can operate, WLC can operate, the deployment and all that. Basics of the wireless you must also know. Our content doesn't say that you have to start the wireless from the scratch and go all the way to the end. Our content says that how to add the WLC, how to add the access point in the SDA. So in your course, you will have, by the way, in your course, you will have some wireless trainings, wireless videos, just the basic videos regarding the wireless. It's already there in your course right here. In your course, if you go to your course at the very end, some additional wireless videos. These videos, I would say that you go through these videos. Wireless will cover at the very end of our content, so you have like quite a lot of time. You have quite a lot of time. You can go through all these concepts of the wireless. These are very basic things, probably the CCNA level stuff. So these are like very basic things that you can go through. In fact, there is some lab also. There's some lab here also. I have built a basic lab in the Cisco Packet Tracer using the access point, using the WLC, how to add it. So very small videos, 10, 15 minutes. So I would recommend you to at least go through these videos to know a little bit about the wireless access point, WLC deployment, how they interact and all that, that part. So these are the things that you must know. These are the things that you must know before you start with your SDA content. It's not going to be like it is not like we are going to start the routing first, then the SDA. Like we will first talk about the BGP, then SDA. It's not going to work like that, because it will take then like a lot of time to complete the content. So some basic to intermediate level of knowledge is required about switching, about routing, about VRF, about some wireless, some basic stuff you must know before you can begin. You can start with your SDA classes. This is my expectation, at least from you, that you should know about these things. We'll talk about, like, for example, we'll talk about like list from the scratch. We'll talk about VXLAN from the scratch. We'll talk about the fabric from the scratch. We'll talk about ICE. We'll talk about the basic things about ICE deployment and all that thing, the WLC integration and all. But we're not going to talk about like what is access point, what is WLC, what is routing, what is switching, what is EIGRP. These things we are not doing. So it will make more sense. Whatever topics we are going to cover later on from the practical point of view, such as like handoff and all, it will make more sense when you have the understanding of those topics, at least a little bit, at least some basics. At least if you have those basic understanding, it will be good for you to ask the questions. Like, you can ask the questions based on that. You will be able to understand what things we are going to cover a little bit better. So if you don't have the knowledge about these things, you still have a lot of time. We'll take some time to reach to that point where we have to know about the VRF and all that thing. So you can watch some YouTube videos maybe for the VRF, for the basics of routing, EI, GRP, BGP, some basic things. You can watch YouTube videos, go through it, and then you can, once we start this content, then you will be able to ask the questions, you will be able to understand the content. We are going to use, like from the lab point of view, I'm going to use a DNS and I'm going to use a total 5 switches. Out of these, some are going to be 3850, some are going to be 9300. We are going to use 2 access points, we are going to use 1 WLC, we are going to use 1 ICE in our deployment. WLC and ICE, these are the 2 products that you can deploy in a virtualized environment, such as like ESXi. Access points you can't. Switches you can. Of course, there are switching images that you can deploy in a virtualized environment, such as EVNG, PNet, for example. If you are still using it, GNS3, for example. But these images that we have, these images that you use in the EVNG, the PNet, the GNS, they will not work with the SDA. There are certain images, there are certain images that Cisco has launched, some Catalyst 9000, some virtual images that you can run on EVNG that are compatible enough, that are capable, that are compatible for the SDA. But those images require way too much resources. One single switching image requires for smooth operation at least 20 to 24 GB of RAM. You can give it like 8-12 GB RAM also, but things might not work well. So like if you want to deploy like SDA capable images in your EVNG, you can look up for the Catalyst 9000 series images, Cat 9K series images, and you will notice that those images consume like a lot of resources, a lot of like RAM, CPU. They consume a lot of resources. So if you are building like a 2-site fabric, it will need like a lot of resources to it. And DNS Center you can't even run on the event. DNS Center, Catalyst Center, you can't even run on the EVNG. We can practice like SD-WAN solution. We can practice routing and switching in the EVNG, but you can't run the DNS Center, Catalyst Center image on the EVNG. You can run the DNS Center, Catalyst Center in a virtualized environment such as ESXi now, but that requires way too much resources also. Minimum like 200, 300 GB RAM. We require like way too much RAM. We require like CPUs, like 40, 44 cores, physical cores we require. We require like in TBs, we require like hard disk, like 2-3 TBs hard disk. We require like too much resources if you want to run the DNS Center in a virtualized environment such as ESXi. And you can't run it on the EVNG by. Even if you manage to get your hands on a server, maybe a server where you have like sufficient resources, like maybe you have a 512 GB RAM, you have like a lot of resources, a lot of CPUs and all that thing. Let's assume that you manage to get your hands on that kind of server, downloading the image from the Cisco website or downloading the images from other sources, installing it in the virtualized environment, the ESXi, then running the EVNG, integrating and all that thing. It is not a very successful task actually. It has not been like very successful for like a lot. So virtualized solution is not that much available. When it comes to practice, you can't practice the Cisco SDA solution in a virtualized environment. We in our lab environment, whatever practice we are going to do, all the things we are going to do on the hardware. We have a DNS Center, we have some 3850 series switches, we have some 9300 series switches, we have some 9100 series access point, 9105, we have a WLC, we have ICE. All these things are, except for WLC and ICE, all these things are hardware where we are going to do the practice. So there is no virtual solution available. There is no virtual solution available where you can practice the Cisco SD. Unlike SD-WAN solution, you can practice in your home laptop. Maybe if you have a good enough laptop, you can practice in the home laptop, or you can practice in the virtualized environment, such as ESXi and all. You can do that. But for the SD access solution, it is at the moment it is not possible. Maybe later on, someday, like when they release a scaled down version of the DNS Center that you can run directly in the EVNG with some catalyst switches compatible for the SDA. Maybe after some time, maybe after some time period when they release these kind of things, then you will be able to do the labs in a virtualized environment. But at the moment, it's not possible. Again, if you are planning to deploy it in a server environment, you will face a lot of problems, a lot of issues. Like you will have to find the proper images, compatible images. You will have to know about the server, how to do the mapping of the EVNG to the DNS center and all that thing. It is a very time consuming task. It has not been like successful a lot to run the SDA solution in the virtualized environment. So you have two options. There are two things that the Cisco offers where you can go through, that you can use to practice your SDA. One is like you can refer to Cisco dCloud, or they have the DevNet Sandbox. They have Cisco dCloud or they have DevNet Sandbox. This is like you have to like schedule the lab. Here in the DevNet Sandbox, like you will have to reserve the lab. You will have to reserve the lab. Like you can reserve a 6 hours, 8 hour slot, and then you can practice in that reserved slot. But what I have experienced, what I have the feedback that I have got about the DevNet Sandbox regarding the SDA, it's no good. It lags a lot. Like your connection will be disconnected quite a lot. Like it's very slow. You might not be able to perform quite a lot of tasks in there. So it's not like very good. Not at least as of now. You might not even get the slots actually. So since like you'll have to make the reservation basically, you'll have to reserve the lab. Once you reserve the lab, then only you will be able to practice it there. So the feedback of this DevNet Sandbox when it comes to SDA is not actually very good. SDA, the dCloud, however, on the Cisco dCloud, you have always on DNS Center, Catalyst Center deployed that you can use anytime you want. Like there is no like scheduling, there is no reservation that you need to do. And you do have read and write both access. I would not say like completely, but you do have read and write both. All you have to do is to just have a Cisco account. You just have a Cisco ID. You just have a Cisco account. If you don't have a Cisco account, you can just create a Cisco account and just search Cisco dCloud. Just search Cisco dCloud. You just search Cisco dCloud on the Google. You just search Cisco dCloud. Just log in with your Cisco account. Log in here. If you don't have a Cisco account, you can create a Cisco account. Just log in with my Cisco account here. By the way, it's not like it's a very special account or it's any special account. It's just a normal like the ID from where you have logged into Cisco ID. So it's the same thing, like nothing special here, right? And you can just log in there, right? So you have logged into Cisco dCloud here. Go to the catalog at the top. Go to the catalog option here. And here you have like a lot of demos. Here you have like a lot of demos that you can explore without any reservation, always on, with both read and write access. Not all the demos are with read and write access, but like for example, the SDA demo, it's for the read and write access. From the top data center, I have selected US East data center. You can change the data center if you want to, but I would say like stick to the US East location like only. So RTP US East, and either you scroll down and you will see these different demos that they have for different things, different technologies. Cisco Catalyst Center Automation and Assurance, for example, 24 February 2020. You can explore this, you can get this. This is instant demo. Cisco Catalyst Center Automation and Assurance version, which version you want to practice? 2.3.5, 2.3.7, 3.1. It's all, by the way, if you take a look at here, it's all, by the way, Catalyst Center. It's just, again, by the way, the name. So just click on it. For example, try 2.3.7 is what we are going to use, by the way. This is what we are going to use, 2.3.7. A username demo1234, by the way. Demo1234. Just try it. Click on the try it button. It will open in a new tab. This is how your DNS Center, Catalyst Center will load here. You can also, if you want to work on a newer version, you can also select this one. This is like version 3. So version 2, then version 3. You can click on that. Early access demo. You can try that one as well. If you want to work on some older version, the one that is in the exam, that you can try also. So there are three different demos that they offer based on like if your company is already using the DNS Center, you can see like which one they are using. These are the stable releases, by the way. So you can select the one and you can just log into that DNS Center. Username password, by the way, is written right here, demo 1 2 3 4. Right. So whichever one works, it will work like demo and demo 1 2 3 4. Demo 1 2 3 4 exclamation mark and just log in. So this will log in you to the DNS Center Catalyst Center dashboard. And from here, you will have the access of the DNS Center Catalyst Center. Not only, by the way, it's not read only. It's read and write both. It takes some time to load, but this is the user interface of the DNS Center. This is the user interface of the Catalyst Center. Here they have already onboarded several devices. They have already onboarded like 83 devices, 61 sites. They have the demo ready for you. You can explore this DNS Center Catalyst Center user interface from here. Everything that is available in a real DNS Center, in an actual DNS Center that you will deploy in your production environment, the one that we will work on, everything is available here. And that too, not only read only. You can go to the design, by the way, for example. You can go to the network hierarchy, for example. And right from here, you will see all the sites and everything that they have created. These are all the sites that they have created, Asia, Europe, and whatever. You want to create your own site, you can add the area, so whatever, we'll cover it later on. I'm just giving you the demo, Cisco, for example. So the new site, Cisco, is added there. Now you can add another area, such as add area, maybe like, Delhi, whatever, Delhi, for example. So under the Cisco, we have now added another area called Delhi. In the Delhi, I can add a building, for example, IMEDITA Delhi, for example, address and longitude, latitude, whatever. So it's not, by the way, it is not read only. As you can see, you created the site, it is present. You created the site, it is present. You created the building, it is present. It's not read only, it's read and write both. So you can when we in our content talk about the network hierarchy, what things we can do under the network hierarchy, you can explore those options from there. When we talk about the settings that we can configure, different settings that we can configure, you can explore, you can configure the things right from there. It's by the way, it's not only read only, it is read and write both. You can see the plus button is still there. You can do the read and write, you can do read and write, you can do both of the things, you can do both read and write things from here. You can create the credentials, by the way. Go to the device credentials at the global, for example, and you see manage credentials. Tab. If the click is not working, then tab. Press tab, enter. You can see the credentials. You can create the credentials. You see? So it's not read only. It is not read only. It is read and write both. Go to the pools, IP address pool. You are at the global, you want to create an IP address pool, you can create it. Then you can go to the site level and then you can reserve it. It's all the options are basically present. Same goes for the wireless. You want to, for example, create an SSID or you want to do certain wireless related things. They will give you certain level of read and write access both on this dCloud, on this Cisco. You can create under the policy, for example, you can go to the group-based access control. This is the, they already have integrated the DNS Center with the identity services engine. From here, you can not only monitor the things for now, you can also go to the security group. Can you create the security group? Tab. Press the tab. Yeah. Here, the click is not working. So click on tab. Tab. Create the security group such as IMEDITA, whatever. Can I create it? Save. Done. Okay. Create the policy. Can I create the access control policies? Can I control that the guests can't access the cameras? Okay. Click on it. Change contract. Deny. I'm not saying that you have to know what I'm doing at the moment. I'm just saying that just take a look at that. We don't only have the read, but also write access on this dCloud. See, done, deployed. You might not be able to verify it, but the deployment is done, deployed. You can create the security groups. You can create the access contract. You can create the policies. Okay, but can you provision? Can you check about the device information? Yes, definitely. Go to the provision. Go to the inventory, and here, for example, of course, you will not be able to add a new device. Of course, you will not be able to add the new device. You don't have the credentials and things. but click on it, action, inventory, delete the device. They might not allow you to do that, but anyway, the point is that delete the device, delete, next. What I'm trying to say is that when you explore this dCloud option, there's no scheduling required, there's no reservation required. What I'm trying to say, you can get, they will not allow you to do certain things, but you can get complete, like almost everything. I would say whatever things we are in our classes regarding the DNS Center, I say that you will be able to complete like 60-70%, 70% of the things in the dCloud itself without any reservation, without any like scheduling of the lab or anything. You can practice like things on the Cisco dCloud itself. At least the relevant part of our content you will be able to complete on the Cisco dCloud itself. You can't build the home lab for this like the DNS, like the SD-WAN. You can't do that. Remote access of the lab is also not possible. We can't provide you the lab access as of now. The reason because like okay, why? So since we have the physical devices, it is possible for us to give you the remote access. But the problem in that approach is that, let's say there are like several candidates. Let's say there are like 16 candidates in the meeting at the moment, 15 candidates. Let's say I have given the access to one candidate. You know, for let's say 4 hours, for let's say 6 hours, we have given an access. So what happens, like the candidate will log in, the candidate will do all the things. First of all, I have to wipe the DNS center. I have to wipe all the switches and everything from the scratch. Like I will have to reset everything, or the candidate can do the reset themselves. The problem is DNS center. When you wipe the DNS center, when you reset the DNS center, it takes a lot of time for the DNS center to come up again, enable all the services. Remember, it's the vManage, the Catalyst Center, the Cisco Catalyst Center Manager. It's like 3-4 GB image. That Catalyst Center takes like 30-35 minutes. That vManage takes like 30-35 minutes to boot up. This DNS Center image is approximately 30-40 GB. When we reset it, it takes sometimes like 2 hours, sometimes 3 hours. Sometimes when it reboots, the services doesn't get enabled for like next 30 minutes, 40 minutes, 50 minutes. So even if we want to give you the access, it's not possible. It is not feasible actually for us to give you the access of the physical infrastructure because of the time and everything that it takes to reset, the reboot DNS center and then enable all the services like HTTPS services. Then this DNS center, by the way, how many services it is running? Let me show you quickly. This DNS center that is deployed, it is running currently 134 services. Until these 134 services come up properly, you will not get proper access of the DNS center. It is just not feasible. Not only for us, it's not feasible for like anyone. So 34, 35 services are running, 34 services. Until every service is up and running, it will show you a log message. It will show you a message at the very top that DNS center services are not running properly. Wait for the services to get enabled and also. It takes a lot time, basically, because of which like it is not possible to give the access to the candidates, even on the remote access basis. We provide the SD-WAN lab, but in the SD-WAN lab, if you have taken the SD-WAN lab access, I'm pretty much sure that you must have faced a lot of issues. The solution is like that. We can't do anything. We have a server where we have deployed that SD-WAN lab. A server that has 512 GB RAM. There we are giving the access to you and you alone. At that time, no one else is practicing on that particular lab. But even then, that DNS, SD-WAN solution, the vManage, it sometimes it takes 30 minutes, sometimes it takes 40 minutes to provide the GUI access. And it is like that. 30-40 minutes you can wait, but you possibly can't wait like for 3 hours, 4 hours for the access of the Catalyst Center. So the point I'm trying to make is that it is not feasible for us to provide you the lab access of the DNS center of the SDA, but 60 to 70% thing, a lot of things you can definitely practice. You can explore all these options, by the way. You do have the read and write both access. You can do the handoff and all those things. I will show you. You go to the provision, you go to the fabric site, for example, you can create the fabric site, you can create the VNs, you can create the transits. You have both read and write access, by the way. See? Create the transit. I will say test 1, IP transit 65001, whatever. Next, deploy, next. You can create the transit. You can go through the process of creating the transit. Once done, Then you can do the handoff. For example, you can go to the Fabric site. You can click on the Fabric site. There are two Fabric sites. You can click on it, London 1, London 2, for example. And there are several devices in there. You can set up the roles. For example, you want to set up the roles. You want to remove the roles from the devices. For example, this is the device. You want to set up the roles on this device. Definitely, you can set up the roles from the device here. Edge node, control plane node, border node, whatever. L3 handoff, AS number, the transit. You can explore the options. I'm not saying that you can do 100%. No, definitely not. But you can easily do like 60-70% things in the Cisco dCloud. You can explore the options that are available in the Cisco dCloud. It is with both read and write access. It is with both read and write access. You will be able to interact with the Catalyst Center user interface in both read and write way. So you can do plenty of things on the Cisco dCloud itself. At least the part that is relevant to us. A few things you can't do, of course. You can't add a new device, for example. You can't delete the device. There will definitely be certain limitations, 100%. But whatever things we are covering in the classes, you can watch the recordings a few times. You can create some notes if you want to. Then you can practice on the dCloud as much as you can. And that will be good enough, to be honest, for you to deploy the SDA solution or work on the SDA solution in your production environment. This is the limitation that we have currently when it comes to the lab. You will have to at least do some compromise from the lab point of view. But at least on the dCloud, you can do plenty of things. At least on the dCloud, you can do like plenty of things. So you can create the VNs. We'll explore the options throughout the content. Time will also show you like how can you do these things in the dCloud and all. But point I'm trying to make is that since it's not possible to make the lab access feasible for the candidates, you will have to rely on the dCloud to practice at least 60-70% of the labs on this.
So do we get your lab access? We will get your IMEDITA lab access, or
no? That's what I explained. There's no such thing. So I will be practicing everything. I will show everything on the physical devices, the resources that we have. I already explained you. Like we have one physical DNS center. We have some physical switches, some access point. All of them are connected. We'll set up the things from the scratch. But the remote access of that lab will not be possible. From the lab point of view, this is where you can explore plenty of things, 70, 60, 70, 75% things you can explore here. You will not be able to do all the things, of course. It's not like only yes, like you will not get the SDA lab access because it's not a virtual solution as of now. It's not a complete feasible. It's not a completely working virtual solution as of now. There are a lot of challenges that people are facing. There's no like DNS center for the ENG or PNet or that kind of thing. So virtual solution is not at the moment available. If it is available later on, then you can build the lab at your home environment. But meanwhile, you can practice most of the things, a lot of things on the Cisco dCloud. Lab access will not be possible for us to provide you because again, it's not virtualized solution. There are physical devices. Even if I try to give you the access of those physical devices, wiping all those physical devices, resetting the DNS center, then waiting for 3 hours for the user interface to come up, it is just not feasible. So we do not provide the lab access for the DNS center for the Catalyst Center. But alternatively, you can practice again as the content progresses, as we begin our content, you will notice that we can practice like more and more things on the dCloud. The solution is pretty stable. A lot of candidates have practiced it. Like I have taken like a few batches of the SDA. And I recommend all the candidates to do like whatever labs they can do on the dCloud, and they are quite satisfied with it. Of course, like you can't do like everything that you will have to compromise on, but you can do plenty of things. Another use of this dCloud DNS Center is like, let's say, for example, you have some client whom you are pitching the SDA solution, the DNS Center solution. You don't need to have like a physical thing set up. You can just spin up this a dCloud demo, and then you can pitch your solution. You can tell the client the SDA solution, the benefits, and all that thing. Since you have the read and write both access, at least up to a certain level, you will be able to explain the benefits, explain the use cases of the DNS Center, the things that you can do from the monitoring point of view and all that thing. So you will be able to explain all these things from here itself. So it's like, it's an advantage, of course, right? So that is how we are going to, uh, uh, I'm going to do everything on the physical devices. I am currently on the premises. I'm from here itself. I'm going to access all the switches. I have the DNS center up and running in our environment. I have the DNS center up and running in my environment. Just yesterday, I finished one of my weekend class for the SDA, and I can definitely show you. This is the DNS center that I am using, by the way, Catalyst Center DNS center that I'm using. It's all set up. It's all completely like set up. We have built in this in the previous class. I have onboarded like a total 8 devices. We have built some fabric. We have different sites and all. Plenty of devices here. Some switches are there. Some switches are there. 5 switches are there total. One wireless LAN controller is there. Then we have some access points as well. These are physical devices, by the way. This is 9105 series access points. It's a proper physical access point. It's not virtual. It's a physical access point. It's a physical switch. The 9300, the Catalyst 3850. These are the physical switches that I am using in our lab deployment. And the design and all that thing. I have set up this completely from the scratch. So I will do again. I will wipe this complete, like all the switches, all the DNS center. Maybe it will take 2-3 hours to reset all the things. I will do that, and then you see that we will be able to achieve the same things that you can see right here as of now by the end of our class. So DNS center, then ICE is also there. 192.168.10. I believe to 38 ICE. We also worked on the ICE. We also worked on 192.168.10.119. That is a wireless LAN controller, WLC. So from the ICE we built the policies. By the way, here under the policies we built the policies here.
Sir, sorry to interrupt you.
Yes.
Sir, which model you are going to use for WLC?
Which model? It is 9800 CL.
Oh, okay, sir. Thanks.
It is 9800 cloud based. This we are going to set up. We're working on 17.15. We will set it up from the scratch with the help of the DNS center. How to add the WLC to the DNS center, how to propagate the SSIDs, the access point onboarding. The client at the moment is not there because, again, at the moment no one is connected there. I can definitely connect there. So this is what this is at the end. This is at the end of the content. By the end of the content, you will be able to. At the end of the content, you will be able to get the same things that you are able to see right here. Like you will be able to achieve the same exact thing by the end of our content, as you can see right here. So I just connected, since I am at the office. I just connected. This is me. I just connected to that AP, the access point. I am able to get the IP and everything. You see, this is my mobile device that I have connected with this access point, running Android and so.
Sir, one quick question. So can you go to 360 view?
Sorry?
360 view, the client 360 view. Yeah. No, in the same WLC. No. Yeah, okay. So if you click the 360 view, so you have the RFI, the value minus 79 dBm, right? So it is the weak coverage. So how we can troubleshoot in the DNAC?
No, part of the it has nothing to do with the DNS center. Like these are the things you will have to manage from the wireless
Can we
point
get the notification on there?
No, on the client, on the DNS center point of view, you can go to the assurance, you can go to the help, you can click on the client. Once the client gets connected, you can get the information here, actually, one connected client, and you can get certain level of information on. Of course, you will not get like all the things. You can get certain level of things like the wireless user. It doesn't display like things all immediately. It will take some time, but you will get almost like less, I would say, like in the client 360, you will get like some information about the client, but from the troubleshooting or the notification point of view, not a lot of options are there. This is what you get under the client.
Okay, sorry. One more question. So I know it is not a part of this class. Okay, and you will discuss in the later class. Right now, your DANS sender is registered in the public domain, IMEDITA.com, right?
Okay.
Okay, if we registered in the IMEDITA.local, is there any challenges?
This DNS center currently, like you can use the maglev wizard and you can try to change the domain name, you can change the settings, but
But
then
the
in that
problem is
case,
the licensing part, there will be issues, right?
yes. I was coming to that point. Maybe the devices that you have onboarded will face the issues. The devices that you have onboarded will face the issues. Yes, from the license point of view or from the
Whenever we
onboarding
are
from the
installing, so we need to have a public site.
yes, correct. And it's the same thing on the vManage as well, the SD-WAN as well. Once the org name is set up, you can't change the org. So yeah, some limitations are there. It's not a perfect solution. There are a lot of issues in the DNS center. One of the biggest thing that we have about the DNS center is that there's no virtualized solution to practice on. So whatever problems you will face it on the real production environment directly. So that is definitely one thing.
So, still Cisco is challenging that. I don't know.
Yes. A lot of I have heard the feedback of this Catalyst Center from a lot of candidates that it's not very stable. We do have a group, by the way, for the SDA that I will share by the end of this week once it's confirmed. Like the final candidates, the list of like the final candidates on Thursday, most probably I will share the link of that WhatsApp group. There you can join, there you can connect, and there are a few candidates there who are working on the DNS Center, Catalyst Center. If you are facing some issues, some challenges, you can drop a message in that group. Someone will respond. Otherwise, I will respond. So
Yeah, that is very good. Yeah, because
that
I
thing.
worked on the 2.3. After 1 year, I did not touch any DNS standard.
Because there are still a lot of challenges. Even the new version that they have, there are a lot of challenges that candidates are facing. Like it has not matured as much as the SD-WAN solution. To be honest, it will still take some time. I'm not sure like how much, but it will still take some time for this DNS center to be like good enough to reach to that we manage that SD-WAN level. So there are still a lot of challenges, of course. Some of them we will talk about throughout the content, but some of them you will only face in your production environment. Unfortunately, you might have to raise a tag case because not a lot of documentation is available. Some of them you can troubleshoot by yourself. So there will be certain challenges. There will be a lot of challenges, which is also one of the reason that this is the approach that we are going to take for our classes. It will take time. We'll take the things like slow. We'll talk about first of all like what is DNS center, why we need DNS center, what are the challenges in the traditional network, in the LAN side of the network, in the WAN side of the network, in the data center network. Then we'll talk about the DNS center, Catalyst center. By the way, SDA is just one part of it. SD-Access is just one. In order to deploy the SDA, we require the Catalyst center. In the Catalyst center is basically the centralized controller from where we can build our SDA fabric. SDA, however, is just one part of it. We have other things as well, such as if you don't want to deploy the SDA, you just want to do the monitoring. You can use the DNS center, you can use the Catalyst center for the assurance purpose. Understand that DNS center doesn't come under the SDA. DNS center does not come under the SDA. SDA comes under the DNS center. DNS center offers much more things, a lot of other things as well that are not directly part of the SDA. SDA is more focused on the fabric part of the network, how to build the fabric, how the VXLAN, how the Lisp and all that thing will work. It is more focused on that. So we do have like SDA is just one part of the Catalyst Center. SDA is just one part of the Catalyst Center. We have a lot of other things. We'll explore the design workflow. We'll explore the policy workflow. We'll explore the provision workflow. We'll explore the assurance workflow as much as we can. We'll explore the tools. We'll explore the developer toolkit. We'll explore like all these options one by one. Will take time. It will take time, but we'll explore like pretty much like almost all the options, not everything, but pretty much almost all the options that are relevant to our country and in your production environment. ICE also, it's not like we are going to deploy the ICE. We will integrate the ICE with the DNS center. Then we will talk about the AAA, how to create the policies and all. There's a dedicated certification for the ICE in security, SISE. So if you want to know complete in and out of the identity services engine, do this. There are dedicated certification exams for the for the wireless. So if you want to know complete in and out of the wireless, you can join those. Actually, you can cover those. So ICE content, the WLC content is going to be very limited to like onboarding, limited to like connecting the client and all that thing, those things. It will be very, very limited to that. Main focus will be on the parts that we have already gone through the document. Main focus will be on the fabric, underlay, overlay, the transits, the policies, the assurance, software upgrade and all those things. Main focus will be on.
Hi Surendra, Sachin this side. In
Yes.
this part, in SDA, are we going to cover the some like other tools like third-party tools or AI tools, something?
AI tools, we'll talk a little bit about it, but for the AI tools, actually what you need, these things we'll talk about, these tools like discovery, topology, command runner, license, template, these all we are going to cover, security advisories and all those things. But when it comes to like specifically when we talk about like artificial intelligence, the AI concept, these AI tools, you have to have like your Cisco ID associated with the DNA center in order to use those tools actually properly. I can give you a theoretical knowledge of that, but I have not like added my Cisco ID to this Catalyst Center, DNA Center, since we are using it only for the lab purpose. In order to enable the AI network analytics, for example, AI tools, you'll have to add your Cisco ID actually. That I have
Not
not
in
done.
at least some sort of idea.
From the theory point of view, we can talk about the options, that the things that we can get. From the theory point of view, we can cover definitely. But the point is that if you try to like if you want to use these AI based tools, actually AI network analytics and all that thing, for that like it will ask you to first of all like integrate your DNA center with a Cisco ID. And since we are using it only for the training purpose, of course, you know that we can't do that. But I will at least explain what are the AI ML options that they have in the DNS.
Thank you.
We'll almost cover like everything from this dashboard, almost everything. I'm not saying completely, but we'll almost go through like all the things that we have here under the DNA Center, Catalyst Center, and you can explore these things, similar things on the dCloud as well. Again, you will not be able to do like 100%, but you will be able to do like 60-70% on the dCloud.
Thank you.
So we'll not only focus on the SDA. That's what I'm saying. We'll not only focus on the SDA. We'll focus on the SDA a lot, but we'll focus on the other things as well, such as software upgrade. How can we use the DNA Center to upgrade the software? How can we integrate the wireless ICE and all that thing? All those things we'll talk. The only thing that you'll have to compromise on is the lab. That you can, if you do the lab, if you repeat the recordings a few times, if you make a short notes, if you make some short notes, that also, even if you don't do any lab, just watch the recording a few times, understand the concepts well, you will easily be able to do the things in the production environment as well. However, you can repeat those things on the dCloud if you want to, but not necessarily that you have to do. Solution is not completely virtualized yet. Unfortunately, you will have to compromise a little on the lab part. But I will not do that. I will not compromise on that. We do have physical devices and all that. So I will show you everything that I can from the DNA Center, from the ICE, from the C, from the AP, at least the things that are relevant to our content and some production environment. If you think that whatever things we have covered today, if you think that all these things are like relevant, all these things are good enough for your production environment, all these things are okay for your production environment, the content that we have talked about and all that thing, then you can definitely continue with the training. You can take a few more classes to understand what we are going to do and all. It will be. I have cleared my expectations. Like this is what we are going to cover. I hope you have the idea on the topics that we are going to go through completely, theory and lab. So if you think that this is going to be beneficial from your production point of view, or from the lab or the training point of view, then definitely you can keep continuing the classes. Right? If you are more focused on the lab part, then unfortunately you will have to wait until some stable lab solution is available in the market. Then maybe someday once it's available, then maybe you can try to practice on those things. So that is one thing that you can. What I'm trying to say is that only join if you think that this training will be helpful for your production or for the lab exam, like, or the certification point of view. If you think like it's going to be helpful, then only like you should continue with this training. I already explained like all the things, all the limitations that we are going to have from the lab point of view and all that thing. So if you think it's okay, you can get the knowledge from the videos, you can get the knowledge from the labs that I will do. If you think it's okay, then you can definitely continue. This is the content. These are the things that we are going to do from the Cisco SDA. We can now focus on the content. I have cleared all the things regarding the document. So here I'm using the same tool that you are well familiar with. This is Cisco Packet Tracer. And first thing first, we are going to talk about a little bit about the design, how the traditional campus networks are basically designed, and what has changed in the past years. What was the need of this software-defined networking? What are the challenges in the traditional campus area network, and how the SDA has managed to overcome those challenges? Let's first talk about it. So from a traditional network design point of view, either you can, Cisco recommends, or in general, there are two recommendations that are there. When you have to design your enterprise network, either you can follow a two-tier architecture, or you can follow a three-tier architecture. Three-tier architecture means like you are going to have something called an access layer from the design point of view. Then you are going to have something called a distribution layer from the design point of view. And then you are going to have something called a core layer from the design point of view. In case of two-tier architecture, you are going to have just two layers. One is called the access layer, and the second one is called core distribution layer. The functionalities of the core layer and the distribution layers, they are merged together. That is called core distribution layer. In small to medium networks, or maybe like in a network where the amount of traffic is not that much, like in a small to medium network, two-tier architecture works best. But if you want like more and more, like much and much like scalability, or your network is quite big, large to very large campuses, they typically tend to be designed around this three-tier architecture, where we are going to have three layers of design in our campus. It's not like you have to follow it. It is not like you have to design your campus network following the two-tier, three-tier architecture, but it's a recommendation that whenever you design your campus network, you follow either two-tier architecture or three-tier architecture. It makes the network much more scalable. It makes the network actually much more scalable. The traffic flow is efficient. Like, these are the recommendations that you should follow when you have to design your campus. What is the access layer? Access layer is the point of your network where the end users are connected. End users are going to join. End users are going to connect to your network with the help of the access layer. Access layer is the layer from where the end users are connected. End users could be like wired users, wireless users. They all are connected via the or with the help of the access layer. Typically, like for example, here we are going to have some switches, some switches where we have like a lot of ports, such as this is first access layer switch, this is the second access layer switch, third access layer switch, fourth access layer switch. Maybe we have like 4 floors. We have maybe like in one floor we have this is our first floor. In the first floor we have like maybe 3 switches. In the second floor maybe like we have 2 switches. So from the design perspective, these are, for example, these switches are what we refer to as the access layer switches. Access layer is the point in your network from where the end users are typically connected. This is maybe the first floor. This is the second floor. Here some end users are there, like maybe 1 or 2 end users are there. Here some 4 or 5 end users are there. Here some users are there. There are like multiple users, not only 2, 3. Maybe it could be like 10s, 20s number of users are there that are connected to connected to the network with the help of the access layer. It is, by the way, the access layer where we also connect our wireless devices, the access points, for example. The access points, the APs, they are also connected at the access. It is the access layer where we connect our voice over IP phones, for example. If you want to provide the IP services, if you want to send the voice or video traffic over the IP network, then you are going to use these IP phones here. For example, here we have an IP phone. IP phone is a device that is responsible to send your audio video traffic over the IP network. The IP phone actually has in the back of the IP phone, there is a 3-port switch that we can use to connect. We can use this to connect our switch, and from here the PC. In the back of this IP phone, there is a 3-port switch. On one of the port, it's written as PC. On one of the port, it's written as switch. So on this port, I'm going to connect the PC, and on this port, I'm going to connect the switch. No need to go in technicals. Just understand that it is the access layer where we are going to connect our, for example, IP phones as well. It is the access layer where we are going to connect our wireless devices, such as wireless access points. We are going to also connect the wireless access points. We are going to connect the APs. We are going to connect the wireless access points here as well. So let me take some wireless device. Here we have some. Right here, we have some access points. AP. These are some access points that we have. These access points are also connected at actually the access layer. Access layer is where from access layer is the point in your network from where your end users are typically connected. Let me just give me a second. I have to share the class link with one candidate. Just a second. In order to provide now the connectivity, in order to provide the connectivity between these access layer devices, we are going to connect. We are going to use this distribution layer. It is recommended that instead of connecting these access layer devices directly, you connect them with the help of a new layer. That is what we refer to as the distribution layer. So all these access layer devices are going to be connected with the distribution layer switch. Distribution layer switch is going to provide. It is an aggregation point for all the access layer devices. It is always a good idea that you connect. It is always a good idea that you connect these access layer switches with at least two distribution layer switches for redundancy purpose, so that there is some redundancy. We can also connect these distribution switches together with these links could be like 1 links, 2 links, 3 links, 4 links. We can have like more than one link from between the switches. Actually, we can have more than one link. So if you have a small campus network, it is enough. Like if you have like a small to medium campus area network, you do not have like a lot of traffic, for example, you have a small to medium network, then the 2-tier design works best, where we have the access layer, where we have the distribution layer. Access layer is the layer from where the end users are going to be connected. And the distribution layer from the design point of view, is the layer from where distribution layer from the design point of view is the layer from where the access layer switches are interconnected with the help of the distribution layer. Distribution layer provides the aggregation point for the access layer devices. Typically, in a small to medium network, 2-tier is okay. But if you have a large or very large network, in that case, let's say, for example, this is one of your building where we have like a few floors. In every floor, we have a certain like 3, 4, 5 switches. All of them are interconnected with each other with the help of some distribution switches. This is one building that you have. Similarly, let's say, for example, you have another building. Similarly, you have, for example, another building. So if you have like a large, if you are dealing with large or very large campus area network, enterprise network, in that case, it is required that it is suggested that you go for not 2-tier but 3-tier design, where all the distribution layer devices are connected with the help of a new layer. That is what we refer to as a core layer. Again, we are going to connect one or more. Again, minimum at least, like they recommend at least to have like at least 2 switches at the core layer also. Core layer basically provides the core layer in your campus area network provides the aggregation point. It is the aggregation point. Core layer provides the connectivity between the distribution layer devices. If you're not dealing with like a very large campus network, 2-tier works best. But if you're dealing with like large to very large campus network, then they recommend that you go for the 3-tier design, where we are going to introduce another layer in the design, which is what we refer to as the as the core layer. Remember, more layer that you introduce, more chances of latency. So if let's say, for example, a certain application is running in your data center and the users are required to access those applications, if the traffic is passing via access and distribution only, it's fine. But if the traffic is passing via the access, distribution, and core, of course, it will introduce a little bit latency as well. Which is also one reason that they recommend going for the 2-tier in most of the cases, if it is possible. But 2-tier works the best. But in a large to very large campus network, 3-tier. In a large to very large campus network, 3-tier is also recommended. So this is one building that we have. In this building, we have some wired devices, some wireless devices, some IP phones, some access layer switches, some distribution switches, some core switches. Maybe like, we can connect these core switches for the external connectivity, for the connectivity with the rest of the network or rest of the enterprise outside of our campus network. We are going to have some routers as well. This router provides the connectivity with the outside known network, such as your data centers, such as your headquarters, other branches, with the help of technology such as like maybe simple WAN technology such as like VPN, DMVPN, or maybe like some private WAN technologies such as MPLS. So this is one router that is connecting our campus network to the outside a known network. This is connecting to outside some known network, outside known network such as your data center, headquarter, and all that thing. So I'm going to just connecting to some outside known network. Example would be like such as data center, such as headquarter, such as your other branches, for example. These are going to be some typical example of the outside. How the connectivity is being provided? Maybe the connectivity is being provided with the help of some VPN setup. This is WAN router. This is your other branch router, and the connectivity is being provided with the help of some VPN, maybe some GRE, some DM VPN, or maybe some private transport such as MPLS. Who knows? We really do not care about the WAN part at all. These core switches, or maybe the distribution switches, if you are going for the two-tier design, this link will come to the distribution layer. If you are dealing with the three-tier design, then the link is getting terminated at the core. Maybe you also have a link going towards outside unknown network. Outside unknown network, such as, for example, there is also a link going towards outside unknown network. The outside unknown network would be, for example, the internet. Outside unknown network is going to be, for example, outside unknown network will be, for example, internet, cloud. You are providing the connectivity with those internet routers, just the basic, internet, like ISP. You have some internet service providers. ISPs are responsible to provide you the reachability to the internet and all that. So we have taken the connection from some service providers such as like maybe AT&T, Airtel, whatever. Like you have taken some connectivity. Instead of using a router, you can terminate the link maybe on a firewall. Here you can define your security rules, what traffic can come inside, what traffic can go outside, and all that thing. So that is completely up to you. There are going to be like other devices, like in your campus network. You can have a dedicated, for example, if you're talking about like a branch network, if you're talking about like a headquarter, for example, you can have some servers that you want. Like every device must be able to access those servers and all. Maybe like we are going to manage all these access points. We are going to manage all these access points from a centralized controller. That is what we refer to as the WLC, wireless LAN controller. So we are also going to have some WLC, wireless LAN controller, installed maybe connected at the distribution layer, maybe connected at the core layer, maybe connected at our data center, for example. Who knows how you have done the connect. This is like the two-tier design or three-tier design is typically recommended for your enterprise network. We typically design our enterprise network following this two-tier or three-tier architecture. Here, distribution layers is the distribution layer that we have. It is the boundary. The distribution layer switches, they act as the boundary between the routing and switching. Again, completely subjected to the design. Again, completely subjected to the design. It is the distribution layer that acts as a boundary between the routing and switching. Here, from the design perspective, again, here we are going to have like, typically we are going to have like L3, like we are going to have routing. And typically here we are going to have from the distribution to the access side, we are going to have L2, that is going to be switching, and distribution to the core side, we are going to have L3, which is so all these links, by the way, all these links that we have, all these links are L3 links. What do we mean by L3 links? L3 links basically means like here, we have configured, we have run the command called no switch port. No switch port is going to convert these links as the L3 links. And then we can configure the IP address. Then we can configure the IP address on that link. It's L3. Here, like all these links on the downward sides here, these are like L2 links. L2 links like that cannot be configured with the IP. Here we configure like VLAN, trunks. Here we will have our switching running. Here we will have our VLAN and trunks. That topic basically, that thing runs here at this. This is called, by the way, technically speaking, this is called STP-based access layer. This is called, by the way, STP-based access layer. STP-based access layer means that STP-based access layer basically means that here we are running the spanning tree protocol. Here we are the links between the access layer and the distribution layer. These are like the layer 2 links. Here we are running our VLAN, trunks, Ether channel, STP, VTP, DTP. All these things are basically running here. This is HTTP based access layer. Switching, routing. These distribution layer switches will act as the default gate for the access layer devices. Some devices are part of the VLAN 10, some devices are part of the VLAN 20, some devices are part of the VLAN 100, for example. So these switches are going to provide the gateway services. These devices are going to work as the default gateway for the VLAN 10 user, for the 20 user, for the 30 user, for the 100. Since we have two distribution layer switches, I can configure both of them as the default gateway, and then we can run the first hop redundancy protocols such as HSRP, VRRP. We can run these protocols to make the gateway redundant. We are going to configure these distributions such as the default gateway for VLAN 10, VLAN 20, VLAN 30, VLAN 100 users with the help of this thing called SVIE, Switch Virtual Interface. We are going to configure SVIE for VLAN 10. We are going to configure SVI for VLAN 20, SVI for VLAN 30, SVI for VLAN 100. And using these SVIs will act as the default gateway for these interface VLAN 10. Interface like a layer 3 interface. A layer 3 interface for a VLAN is called an SVI, Switch Virtual Interface. Since we are not going to convert these interfaces into the L3 interfaces by the command no switch port, I can configure an L3 interface for the particular VLAN called an SVI, interface VLAN 10, interface VLAN 20, interface VLAN 30, and then I can configure the IP address such as 192.168.10.1, 20.1, 30.1 here, 10.2, 20.2, 30.2 there, and then we can configure between the two. We can configure HSRP, VRRP, for example, so that they act as active standby gateways for the end users. End users are going to send the traffic to the gateways if they want to go outside the network. The gateway will then perform, the distribution switches will then perform the routing, and then they will route the traffic from the LAN side to the core side to the outside using the entries available in the routing table. We can run protocols such as OSPF, we can run protocols such as EIGRP to make the reachability. Problems in this approach? What are the challenges then? But this is a typical campus design. This is a typical campus. We can introduce like more and more things. Let's not complicate it. Let's not introduce the firewalls and all that thing, IPS, IDS. This is a typical enterprise network design from our enterprise infrastructure point, from our routing and switching point of view, for example. This is how a traditional network design looks like. We can have more things here, such as we can have firewalls, IPS, and all those security appliances as well, but let's not introduce. For many years, like the typical enterprise network is designed following the 2-tier or 3-tier architecture. So what are the challenges in this? There are several challenges in this 2-tier or 3-tier architecture. First of all, the traditional network design follows this thing called STP-based access layer, where between the access layer and distribution layer, between the access layer and the distribution layer, we are running switching. We are configured, we are running here switching. STP, DTP, trunk, all these things are basically running here. All those things are sending all those like protocols, such as if I have configured, let's say for example 5 or 10 VLANs here, then STP is responsible to prevent the loop for those 5-10 VLANs. In order to do that, STP will send and receive some messages, which what you call, by the way, if you remember, BPDU, Bridge Protocol Data Unit. BPDUs will be sent for Bridge Protocol Data Unit. BPDUs will be sent for VLAN 1, 2, 3, 4, 10, 20, for all the VLANs. In every 2 seconds, by the way, there is definitely going to be some overhead on the links. These links are basically going to handle those STP messages, for example. DTP, trunk. Every time the traffic arrives onto the switch is going to encapsulate that data with .1q header. It is going to add that 4 bytes of extra information on the data. Every time the packet leaves that trunk link, of course, these things you already know, but the overhead is there. Protocols such as HSRP, VRRP, GLBP, they are going to send the messages of their own. HSRP hello messages are being sent. VRRP messages are being sent because, of course, you wanted to introduce the redundancy for the default gateways, so HSRP, VRRP. So in short, basically here, too much overhead, overhead on the links for those protocols. One of the challenge. Second, how are we going to manage all these devices? This is just one of our branch, by the way. This is just one of our branch. Here we have like 1, 2, 3, 4, 5, 6, 7, 8, 9. If we have like many more floors, we can have like 10s or 20s or 30s of like number of switches here. We have like a 10 floor building. In every floor, we have like 3, 4 switches. So overall, like 30, 40 switches in one building, 30, 40 switches in second building, 30, 40 switches in third building. How are we going to manage all those switches? Management related challenges. If the user reports that I'm not able to access the network, we'll need to find out, for example, that the user is connected at the access layer switch number 2 in the building number 4. So I'm going to find out the IP address of that particular switch. Then I'm going to do the SSH or telnet, and then I will try to troubleshoot what exactly is the problem, why the user is not able to access the network. Wireless devices, management of not only wired, but also the wireless devices. We have access points, we have IP phones, we have different types of devices in our network. We have both wired users, wireless users, WLCs, access point switches. How are we going to manage so many devices one by one, box by box, for example? Doing telnet SSH on all these devices, of course, is not a very feasible idea. You might use certain tools for the same. Your company might use certain tools to manage all those devices from a centralized point. Okay, fine. So management related challenges are going to be there. Your network now needs to be scaled. 2 new or 3 new branches needs to be set up. And in those 3 new branches, you again have to install like approximately 10, 20 switches following the 2-tier or 3-tier design. So you design the 2-tier or 3-tier architecture based on the requirement of the branches, and then you started doing the configuration of VLAN, trunks, VTP, GTP, STP, routing, this, that. You started doing all that configuration. Of course, it is going to take certain time before you are able to deploy all these branches. So deployment related challenges. Deployment, like if you have to install a new device, or you have to install or set up a new branch, there manual overhead, administrative overhead is going to be there. It will take certain time. It will take some time to install those devices in your new branches, new campus network. Even if you try to copy paste, even if you just try to do the copy paste from the configuration from one branch to other branch, you need to be careful. You need to change certain values, like maybe the network you need to change in the router OSPF. Maybe you need to change the neighbor command in the BGP. Maybe you need to configure some different VLANs, different IPs for the SVIs and all. Even doing the copy paste, is going to take some administrative overhead. Deployment, operational challenges. Everything is everything is working fine, everything is up and running in your production environment. Suddenly, certain users started reporting the issues. How are you going to troubleshoot those issues? How will you be able to find out where the issues are, where the user is connected? How are you going to get the better insights of your network, like what kind of traffic the user is sending? Let's make sure that the user is not sending some sensitive information, outside the network. Some users are reporting the issues in day-to-day operation. They are saying that our latency to access those applications is quite high. So there are going to be some operational challenges as well. Yeah, sorry. As soon as you did the upgrade on certain switches, some users started reporting the issues. Basically, point is that in day-to-day, there are going to be several operational challenges as well. Like you will need to troubleshoot the client issues, you need to troubleshoot the user issues, you should be able to see what kind of traffic or how the user experience is there for certain applications, configure the policies to rectify it, to correct it. Basically, there are going to be day-to-day operational challenges as well. What about the security? I want HR department to not communicate with the finance department. So we configured this thing called VLAN. With the help of the VLAN, I configured HR department users in VLAN 10, finance department user in VLAN 20. But then, you were able to achieve the separation with the help of the VLAN. But then you also configured the SVI for VLAN 10 and SVI for VLAN 20. But then you also configured this IP as the default gateway, this IP as the default gateway. So with the help of the distribution layer switch, they will be able to communicate with each other. You are able to achieve the separation between the departments at layer 2 with the help of the VLAN. But as soon as the things reach to the distribution, as soon as the things reach to the routing level, of course, VLAN 10 users can communicate then with VLAN 20. Configure the access list. Who can configure like what? Who can access what? Who can communicate with what users? What can access? What users can access? What services and not? You need to configure the ACLs. You can enforce the security to restrict or permit the communication between the users, applications, servers, and all with the help of the access control list. How many ACLs you are going to create? In an enterprise network, a typical ACL can have like thousands of lines. Configuring the access control list on the switches, on the routers, in your enterprise network to restrict the access or permit the access is just not going to scale well. Security related challenges. We can enforce the security in our enterprise network with the help of the VLAN, with the help of the access list, but the concept of the VLAN, the concept of the access list does not scale very well. What if I'm not even using the Cisco switches? What if like I'm using like at the access layer, I'm using Cisco switches, but on the distribution layer, I'm using some other vendor switches, HP or maybe Juniper or any other vendor switch. What about the interoperability? Remember that Cisco switches run SPAT, for example, STP. Cisco switches run STP in per VLAN mode, which is what we refer to as PVST plus, rapid PVST, but these other vendors, they can only run like the STP. How the interoperability is going to be there? The CLI, the command line interface for these other interface, the commands that you need to run on these other vendor switches might be different than the commands that you need to run on the Cisco switch. Although the output will be same, but the commands are different. You have to think about the configurations that you need to do on vendor by vendor or box by box basis. In a multi-vendor environment, like if you have some Cisco switches, some Juniper switches, some HP devices, vendor by vendor, like you will have to take the access, then vendor by vendor, you have to run the configuration commands and all that.
Sir, sorry to interrupt you. Sir, can we have different switches at distribution layer, like access layer, we are using Cisco switches, and at distribution switch, and at distribution layer, we are using like Juniper.
HP Juniper, yeah, no problem. No problem. You might you might see a lot of production environment when it comes to, for example, core and upper layers. They tend to go for like different vendors. Yeah, completely fine. Which adds a little bit more complexity to your campus network because now you not only have to manage the Cisco devices but the other vendor devices as well. We as a human, we are interacting with all these devices on box by box basis using Telnet, SSH, maybe some web user interface, web UI, we are managing all these devices from Telnet, SSH, console, web user interface, maybe for example, CLI or GUI in short, basically. So, but still we are doing the management like box by box, one by one. Of course, it is going to add the complexities. Of course, it is going to add the challenges in managing the campus area network. It is also not like if you configure VLAN on this switch, it will automatically get created everywhere. It is also not like if you configure like OSPF where it will automatically configure everywhere. It's also not like that. Since every device has its own control plane, data plane, and management plane. From the architecture point of view, every device has these three architectural planes: control plane, management plane, and the data plane. Management plane of the device is responsible to deal with the device management, how the device is being managed. Has the administrator used like SSH, SNMP, CLI? How the administrator, web UI, how the administrator is connecting to the device, how the administrator is accessing the device, how the administrator is managing the device is handled by a part of the device called management plane. Management plane of the device is responsible to deal with the device management. When we configure line console password, when we configure the line VTY password, when we configure the line aux password, typically what we are doing, we are securing our management plane. It is the responsibility of the data plane to perform things such as encapsulation, decapsulation. When the data arrives, encapsulate it and forward it. When the data arrives, decapsulate it and forward it. When the data arrives, like encapsulate, forward it, decapsulate, encapsulate, forward it, like it is the responsibility of the data plane to actually forward the data that goes through the device. through the device. A data that passes through the device is passed with the help of the data plane. Data plane is the part of the device that is responsible. Data plane is the part of the device that is responsible actually to perform things such as encapsulation, decapsulation for the data. The data that passes through the device is passed with the help of the data plane. It is the data plane that is responsible to handle things such as encapsulation, decapsulation. It is the data plane that is responsible to check the routing table, ARP cache, STP, switching, all those type of table. It is responsible, data plane is responsible to check all these tables to make the forwarding decision. And it is the responsibility of the control plane to build these tables. Control plane controls the data plane. Control plane instructs the data plane how the data forwarding should be done. It is the responsibility of the control plane to exchange the STP messages. It is the responsibility of the control plane to exchange the OSPF messages to build those, neighbor table, the database table, the routing table, the STP, the ARP, this, that, different types of table. It is built by the control plane of the device, which is then consulted by the data plane in order to make the forwarding decision. It is the control plane, CPU. It is the control plane where these protocols such as OSPF, EI, gRP, STP, all these protocols run. They run at the CPU level of the device, the control plane level of the device. Control plane in a layman terms, it's CPU. Anything that goes towards any packet that is generated, any packet that goes towards the device, any packet that is for the device itself, it is handled by the control plane or the CPU of the device. Anything that passes through the device, it is handled by the data plane. Point is, every device has its own control plane, data plane, and management plane. It's a distributed architecture. Distributed architecture means every device has its own set of control plane, data plane, and management. Since everyone has its own set of control plane, management plane, data plane, if you want to configure this device, you will have to connect with the management plane of that. If you want to configure this device, then you will have to connect with the management plane of this device. It's not like you can connect using telnet SSH or maybe the console. You can connect to this switch using that, and then you are able to run the commands here. It's not like that. It's not like you can run OSPF only here and it will exchange the route information with everyone. It's not like that. You have to configure OSPF properly everywhere so that they can exchange the route. You have to log in. You have to take the access of all these switches and then configure OSPF on everywhere one by one, so that on all the devices, OSPF starts running at the control plane and they start exchanging the OSPF messages, build the tables and all that. It's not like this device has built a routing table, so this device will forward the data based on that. No, if this device wants to forward the data, the entries must be available in the routing table of this device itself. Like every device must maintain proper routes in the routing table if they want to forward the data. Every device must maintain proper MAC address table if they want to efficiently forward the data. Every device, since they have their own set of control plane, management plane, data plane. Since it's a distributed architecture, we have to manage every device one by one. We have to run the protocols on every device one by one. We'll have to make sure that every device has the entries in their tables so that they can forward the data efficiently one by one. We have to make sure all the devices have proper things. Let's not even talk about, let's not even talk about the cloud. Let's not even talk about IoT. Let's not even talk about this modern day network, where things are not only limited to our data center headquarters, but things are moving to the cloud as well. More and more applications are running on the cloud. Office, MS Office, Microsoft Office, nowadays Office 365, for example. The Dropbox, Google Drive, some CRM applications, things are moving to the cloud. How can we make sure that the user experience for this cloud-delivered application, cloud-delivered services, it is efficient? How it is good enough? User experience is good for the cloud-delivered. Companies are moving their infrastructure to the cloud. Companies are moving their softwares to the cloud. Things like infra as a service, software as a service, platform as a service. Different things are there when it comes to the cloud. Basically, applications and infrastructure is not only limited to nowadays to the data center. It is companies are also opting. Many companies have already deployed their infrastructure, their services, their softwares onto the cloud. Born in a cloud is a concept, by the way. Born in a cloud basically means like the applications are completely developed on the cloud, completely deployed on the cloud, and everyone is able to access those services completely from the cloud. Like they are not hosting anything on their own servers on their own premises. So how can we make sure that the user experience is good for those applications that are deployed on the cloud, the infrastructure that is deployed on the cloud? Basically, the latency issues, several like issues that performance issues, latency issues, jitter, that delay, loss, a lot of factors are there. So the traditional infrastructure is good, but from the modern day point of view, it lacks like quite a lot of things. It makes since now humans are not the only users of the network. Earlier, humans were the only users of the network, but nowadays humans are there. Nowadays, like these softwares are communicating with the software, such as some IoT devices are there, such as some cloud delivered infrastructure is there. Nowadays, not only humans, but software is also communicating with the software. There are different types of devices available in the market. There's a concept called bring your own device. There's a concept called work from home. How are you going to efficiently access your infrastructure that is deployed, that is hosted in your office from your home securely? Not meaning to say that the traditional infrastructure is very bad, but it lacks a lot of things that are needed for a modern day network. The technology, the things have evolved a lot in past like 5-10 years. There are, so briefly, like if you categorize, if you address the issues that we have in a traditional network, there are like deployment related challenges. There are like operational challenges. There are like management related challenges. There are basically several security related challenges. The cloud, if you have hosted, if you are running the services onto the cloud, then there are like those challenges as well. Distributed architecture is there. Since the distributed architecture is there, distributed control plane, data plane, management plane is there. We have to manage the devices box by box. If you are working on different vendors might have different solutions to configure, to manage the devices. You can use tools. I'm not denying that. Your company might or you might use different tools to manage all these devices, but then vendor dependency is also one thing. Vendor lock-in. Different vendors tend to use different tools. They provide different tools to manage the devices. If you have an ASA firewall, for example, if you have an ASA firewall, you can use some tools provided by Cisco to manage those ASA firewall. But if you have a Palo Alto firewall, can you use the same tool? Of course not. Panorama, FTD. I'm not much of a security guy, but at least that much I know that different vendors have different tools. You can use those tools definitely. To manage the devices of the vendor. But again, how many tools you are going to learn?
Surendra sir. Sir, like here, everything is distributed, like management plane also distributed, control plane distributed, and data plane is also distributed. Sir, if I take example of SD-WAN, okay, when we manage our management plane gets centralized, right?
Okay.
When we use smart, our control plane gets
correct. Okay.
So do we have the similar controller here, like for
no. So in order to address these challenges, let me come to that point. In order to address these general challenges that we have in a traditional campus network, challenges are not only from the LAN side of view, the challenges are also from the WAN side of view. You have many routers that you have deployed in your n number of branches. All these routers needs to connect to the outside known network, outside unknown network, the VPN, the internet, the NAT, the firewall rules and all that thing, ACLs and all. You need to configure all these, like for example, routers. Again, similar kind of issues will be there from the WAN side as well. Managing all these WAN edge routers one by one, configuring them with the IP, BGP, the VPN, passwords, and policies and all that thing is again going to be quite challenging. Basically, not only in the LAN but also in the WAN. We do have issues in both LAN and WAN. Same happened in the data center also. In the data center environment, data centers consist of like a lot of servers. On these servers, we are going to use the concept of virtualization. Using the softwares, using this operating system, using this thing called hypervisor, using some sort of like software, we can run several virtual machines. We can run several virtual machines on these servers. We can provide the access to these virtual machine to our client. Clients then can run whatever kind of services, whatever type of softwares they want to run on those servers. Client says that, okay, increase the RAM from 8 GB to 16 GB on that VM. Okay, do one thing, add 2 TB hard disk, 2 TB SSD on that particular VM. Power on that VM, power off that VM. Basically, like management of these servers, the virtual machines, the servers, and all these things is, of course, going to be, we are going to have like same kind of issues in the data center environment as well. In the data center, we don't even follow this 2-tier, 3-tier architecture. We follow something called, in the data center environment, we follow something called a spine leaf topology, where we are going to have some spine switches and we are going to have some leaf switches. Every, for example, spine switch is going to connect to every leaf switch, and every leaf switch is going to connect to every spine switch. This, and this. This is spine, this is leaf. Again, this is not a data center class, but in the data center environment, we follow this thing called a spine leaf. Spine switches, they don't connect together to each other. Leaf switches, they do not connect to each other. The spines connect to leaf, leaf connect to spine, and all the end users, like all the servers, all the routers, everything basically gets connected to the leaf. Data goes, like, in a typical enterprise network, the data goes north, south, up, down. But in the data center environment, the traffic goes east, west, east, west, left, right, not up, down. In a data center environment, also managing all these servers, these spine switches, these leaf switches, different like servers that we have. Of course, like in the data center environment, we are also going to have similar challenges. We also have some routers in the data center environment that are connected to the outside known network, unknown network. We also have to configure the IP address, subnet mask, default gateway, BGP, OSPF, all these things there also. When these issues, like, when these problems that we have in a traditional network, in the problems that we have in a traditional enterprise network, the data center network, when they decided to solve these challenges, they thought, why don't we use softwares? Let's not use humans to manage this infrastructure. Why don't we use some softwares to manage this? In fact, in the data center environment, in the DC, in the data center environment, this concept of software-defined networking came a long time ago, actually. Software-defined approach to manage the data center network, software-defined approach to manage the data center network, software-defined data center was launched. Cisco used to call their data center as, Cisco calls their data center as ACIE. ACIE data center, application-centric infrastructure. Data centers are built around certain applications that they run. Data center networks must be designed around the application that they run, such as file transfer applications, such as data storage applications, maybe, or, online banking, those kind of applications, whatever. Data centers are built around the applications that they serve, hence the name application-centric. They say that if you build a data center network, build it centric to the application that you are running, and then manage this data center network with the help of a controller. Do not manage it, on box by box basis. Do not hire a lot of engineers to manage all the devices like one by one. Instead, you do one thing, you purchase this controller. You purchase this controller called APIC, Application Policy Infrastructure Controller. And from here, you can manage your data center infrastructure in much more efficient way. Here you can configure endpoint policies and groups. There is a concept called endpoint groups, like and policies for them. What kind of users can gain access to what kind of services we can configure. Those policies, we can manage the data center infrastructure from this centralized controller called APIC, Application Policy Infrastructure Controller. ACIE EPIC was born. ACIE EPIC, which solved actually like quite a lot of issues in the data center network, became very popular. Even to the day, like to this day, in the data center environment, you still see the use of ACIE EPIC. It became like very popular solution. This software-defined approach to manage the data center infrastructure became the very popular solution for the DC environment. In fact, it became so popular that they thought, why don't we provide the similar solution for the enterprise network? to challenge, to address the several challenges that we have in the enterprise network. They thought, why don't we offer the similar kind of solution for our enterprise network as well? Why don't we create the same controller for the enterprise network as well? And they did. They created a controller. They created a controller called Epic EM. They created a controller, Epic EM. It was a different product as compared to Epic, Application Policy Infrastructure Controller Enterprise Module, EM. It was specifically targeted for the enterprise network, addressing the challenges that we have in a traditional enterprise network. Unfortunately, this Epic EM could not gain a lot of popularity. Not a lot of enterprise networks opted for the Epic EM. Like, they tried to sell this Epic EM controller, but unfortunately it could not gain as much popularity as the Epic for the data center infrastructure. Hence, like, it was later on discontinued. Meanwhile, in order to manage the enterprise network, other controllers were there. For example, Cisco offers a controller called Prime Infrastructure PIE. It is still a very popular controller to manage the enterprise network. You get like a lot of features in this Prime infrastructure. A lot of features. We'll talk about it, but you get like a lot of features in the Prime infrastructure to manage your campus enterprise network, the wired, the wireless network. Very popular product. Again, to the day, a lot of companies, they use this Prime infrastructure. But this Prime infrastructure has been announced end of sale, end of life, end of support, so around like, I believe 2028, something like that, it will go completely like end of sale, end of life, end of support. They have announced that for the Prime infrastructure. So in the enterprise network, this could not gain, this Epic EM could not gain a lot of popularity. Prime infrastructure, Cisco Prime infrastructure was launched in 2012. This software-defined networking is not a very new thing. It has been there in the market for 10-15 years now. So in January 2012, they announced this Cisco Prime infrastructure. And in 2023, they announced it as end of sale. And the end of support is 2028. It is no longer being sold. It is no longer being sold. But very good product. Meanwhile, in the routing world, in order to address the challenges that we have in our routing, in our WAN side of the network, in order to address these challenges that we have in our campus network, in our data center, for example, headquarter, branches, the WAN edge devices. I do not want to manage these WAN edge devices one by one. I want to manage these WAN edge devices from a centralized point, just like Epic. Software-defined approach to manage the WAN edge device was born, and it was called SD-WAN. There was a company called Viptela. They used to offer these special routers that you can manage from a centralized point, a centralized controller known as vManage. They also, this was a centralized management plane for the WAN edge devices. They also, within the solution of the Viptela SD-WAN, they also used to offer this thing called vSmart, which was the centralized control plane. It was the centralized control plane for the SD-WAN devices. Became very popular. This SD-WAN solution, we were able to take the graphical user interface, the web UI, web user interface of the vManage, and we were able to see like all the WAN edge devices in a dashboard format. I can configure with a few clicks. I can configure like protocols such as OSPF, BGP. Nowadays, we can also do like a lot of things actually. We can configure the policies from a centralized dashboard and all. Became very popular solution. So popular that in 2017, Cisco acquired it. Cisco acquired this Viptela SD-WAN solution, and it became Cisco SD-WAN Viptela. It became Cisco SD-WAN CISCO, Cisco SD-WAN Viptela. In 2017, they did that. Same solution. They just acquired Viptela, and then they just started, branding them as their product, Cisco SD-WAN, and then they launched it in the market. Again, since it was already quite popular, more and more companies started using it. around in 2019-20, it gained like a lot of popularity in around 2019 and 20. When they introduced this as the WAN thing in their official content, there became a dedicated certification exam. They introduced in the CCIE Enterprise Infrastructure lab exam also. It became a very popular solution. For the companies, there were several advantages. You were able to do the labs in a virtualized environment, such as like ENG, test all the things, and once you are satisfied, then you can deploy it in your production environment. Several benefits. We were able to manage all the WAN edge devices from a centralized point. We can configure the protocols, we can configure the policies, we can do a lot of things from a centralized point. This SD-WAN became quite popular for the WAN edge, for the WAN solution, offering a centralized management plane, and a centralized control plane. So you don't need to worry about running protocols such as OSPF on each and every router one by one. No. Meanwhile, other vendors also come. Other vendors, they came and then they offered the SD-WAN solution. Other vendors came and they offered the SD-WAN solution as well. This is like, Versa SD-WAN, VeloCloud, VMware VeloCloud. Nowadays, like even the firewall companies such as like Palo Alto, the Palo Alto SD-WAN, Fortinet SD-WAN, a lot of companies are offering the SD-WAN solution. But at one point, I still remember in 2019-20, I had more batches of the SD-WAN than like CCIE or, any other technology. It was very popular. At that point, if you are looking for a job, even if you just knew what is like SD-WAN, what is the full form of vSmart, vManage, vBond, what are the basic functions, you would have easily gotten the job. It was that popular at that moment. Not a lot of resources were there. Not a lot of documents were there. Slowly, like it was very popular product, but since like people didn't knew a lot of things about it, like they did the testing, all that thing in a virtualized environment. They found out the solution to be quite easy to deploy, quite well built for the production environment, and they deployed it. Like a lot of companies have deployed the SD-WAN nowadays.
Even sir, that time no one is providing lab access of SD-WAN, right? So I-MEDITA at that time that they're providing only like the training. Then I went to another institute. They also providing the training, not providing the lab access. But now
in 2020, I'm not sure like what happened at that time, because for the SD-WAN, we were providing the lab we are providing the lab for quite a long time. Must have been some issue at that moment, because it was also new for us. Like, we spent like a lot of time, deploying the things in a virtualized environment, and to the day, like even right now, like the SD-WAN solution for the lab environment is not built as good as the production environment. You still when you do the lab, even in the virtualized environment, whether you do it on the server, in your home laptop, you will face plenty of issues in SD-WAN virtualized environment.
Right.
But then viptela, vBond, vManage, vSmart, vthis, like, they were like different, like viptela. Then in 2023, Cisco, what they did, they decided to rebrand everything. They decided to rebrand their enterprise, their SDN solution, their enterprise solution. So what they did, they renamed, renamed Viptela SD-WAN with a new word called Catalyst SD-WAN. So nowadays it's just SD-WAN. Nowadays it's just Catalyst SD-WAN. Everything is now Catalyst. Nowadays everything is Catalyst. Catalyst switching, Catalyst routing, Catalyst SD-WAN, Catalyst licensing, everything is Catalyst. Catalyst SD-WAN, Cisco Catalyst SD-WAN. The vManage became Manager. Simple, Manager. vManage, it's no longer vManage. It became Cisco Catalyst SD-WAN Manager. vBond, there is something called vSmart. It became Cisco Catalyst SD-WAN Controller. The vBond, it became like Cisco Catalyst SD-WAN Validator, just changing the names. But the fundamentals, the base, everything remained exactly the same. Very popular product. When this SD-WAN solution started gaining a lot of popularity, they thought, why don't we revive our SDS, our Epic EM as well? Why don't we revive our SDN solution for the campus area network as well? And that they did. They launched the same Epic EM with a new name. They launched the same Epic EM with a new name called DNA Center. Digital Network Architecture, DNA Center, DNAC. It is it is like Epic EM with a lot of assurance feature. A lot of assurance feature. Assurance means like, monitoring and all. Epic EM with a lot of assurance feature is what they call DNS, which is again a controller that you need to purchase. Here it is, right here. It is a controller that you need to purchase and install it somewhere in your network, maybe in your data center, maybe in your branch, whatever. As you can install it like anywhere, as long as you can provide a reachability with that controller. Here is our controller installed in the data center, and with the help of routing, we have provided the reachability for all these devices with that controller. Similarly, we can have, by the way, like I said, similarly, we can have in our data center devices such as wireless LAN controller. From here, we are going to manage our all the access points of different locations. Maybe I can have some authentication servers. We can have some additional things such as some authentication servers such as AAA server in our data center network, and I can authorize all these devices from a centralized point. I hope you get the idea. DNS Center is just Epic EM with assurance feature. It could not, again, this Epic EM could not gain that much popularity at that moment, but then when it was rebranded, relaunched, revived by the name of DNS Center, Cisco again introduced this Cisco DNS Center Catalyst DNS Center basically in the official content of enterprise infrastructure, ENCOR lab exam, for example. So you were left with no other choice than to read about it. And just like the SD-WAN, Cisco says that software-defined approach to manage the campus local area network or an enterprise network, the LAN side of the campus network, is what we refer to as the SD-Access. In other words, it is simply called SD-LAN. A lot of nowadays, like a few more vendors have started providing the SD-LAN services. In Cisco calls it like SD-Access, software-defined access, SDA, where they use this controller called DNS Center in order to manage this campus network from one centralized point and get all the benefits of the software-defined networking for your enterprise network. As in 2023, by the way, when everything was getting rebranded to the Catalyst, DNS Center also got rebranded, renamed. It is now called Catalyst Center. It is now called the Catalyst Center. In 2023, since 2023, all the later versions like version 2 point something, if you work on the versions 2.3, 2.5, 2.7, these versions of the DNS Center, the user interface says that it's Catalyst Center. But under the hood, it's all the same thing. Software-defined approach to manage the data center, CCIE EPIC. Software-defined approach to manage the enterprise campus LAN, software-defined access, with the help of where we use the controller called DNS Center, also known as Catalyst Center nowadays, and software-defined approach to manage the WAN, the wide area network, software-defined approach to manage the WAN or wide area network SD-WAN. So if you want to have the full-fledged SDN capabilities in your network, you need to go for three things: SD-WAN, SD-Access, and just in case if you have a data center, then CCIE EPIC. SD-WAN uses like, there are two flavors, by the way. One is called Catalyst SD-WAN. One is like Meraki SD-WAN. Maybe when you study SD-WAN later on, we will talk about it. SDA is just the DNS Center, also known as Catalyst Center. CCIE EPIC is itself the control. Sooner or later, you will remove the prime infrastructure from your environment and you will migrate or you will switch to the DNS Center or Catalyst. You will have to do it. We will force you to do it, basically. Since the prime infrastructure has been announced end of sale, end of life, of course, like you will have no other choice than to migrate to or switch to the Catalyst Center or maybe Meraki. But one thing to note very, very clearly, one thing that you have to note here, the Cisco SDA solution, Cisco software-defined access solution based on Catalyst Center will give you the capability to manage all these devices from a centralized point. Centralized management will be there. Centralized management will be there. You can do a lot of things. You can do a lot of things like you can manage all these devices from a centralized point. You can do the software upgrade. You can telnet, SSH. You can do like a lot of things from a centralized point. But understand that it will not give you the same flexibility as the control plane. Remember that there is no centralized control plane in this context. There is no centralized control plane in this DNS center, in this SDA concept.
Only sir management plane, right? Will be centralized.
Only we can use the SD-Access, we can use the SDA to manage all these devices from a centralized point. We definitely can push certain configuration on these devices, but there is no centralized control plane. Understand that whether an SDN solution, whether a software-defined networking solution is going to offer you centralized control plane, centralized, what will be centralized? Control plane, management plane, data plane, it completely depends on the SDN solution that you are going to use. For example, if you are going to use the Viptela-based SD-WAN, in that case, the control plane is also centralized and the the management plane is also centralized. Data plane is on the devices itself. But when it comes to like SDA solution, it's more like just the centralized management is being done, centralized management and provisioning is being done from the DNS center, but every device still need to run protocols such as OSPF, ISIS, BGP. They still need to be configured with the IP address and all that thing. All those things still needs to be done on the devices by us. There's no centralized control plane concept in the DNS center. There is a control plane. There is a control plane. There is a control plane node in our SDA solution, but not in the DNS center. Understand what I'm trying to say. There is a dedicated controller in the SD-WAN. There is a dedicated controller that is called vManage, also known as manager nowadays. Centralized management plane. There is a dedicated controller called vSmart, also known as Catalyst SD-WAN controller nowadays, which provides a centralized control plane functionality. Then there's bond, there's this thing called vBond, validator nowadays we call it. There are three controllers. There are three different controllers in the SD-WAN solution. There is no such thing in our SDA. There is just one controller.
Okay, so
Yes.
that case, if any case on the faulty state on the DNS center, there is no impact on the network, right?
Correct.
Okay, so we cannot do any deploy any changes. That's only.
No, you can still do the changes and all that thing by locally connecting to the switch using
Locally
telnet
we can
SSH.
do, but yeah, in the through the DNS center we cannot do anything.
Yes.
Yeah.
But that benefit is also there on the on the SD-WAN. That benefit is also there on the SD-WAN. If the SD-WAN vManage goes down, if the vSmart goes down, there is no impact on the data plane, right? The data traffic will still keep forwarding as it is. That was the whole point of the software-defined. That was the whole point of centralizing the control plane management plane that you just talked about. It is still there in the SD-WAN. But the point is, unlike SD-WAN, we do not have a dedicated controller for our control plane function, centralized control plane functions. We just have Catalyst Center, we just have the DNS Center, which is more like going to manage all these devices from a centralized point. And definitely it can push certain configuration. When we talk about like fabric and all, it can definitely push certain configuration. But if you say that I'm going to push the OSPF configuration and all these devices automatically and all that thing, there's no dedicated controller for the same. There are no three controllers unlike your Cisco SD-WAN solution. There is just one controller. You will get the access, you will get the GUI, you will get the web user interface access of the DNS center, and from there you are going to do all the management, configuration, provisioning, whatever stuff it offers, you can do from that. Understand the wording very carefully. There are in SD-WAN there are three different controllers. But in SD-Access, there is just one controller called DNS Center or the Catalyst Center, from where you are going to do whatever things that are relevant to your SDA environment.
Explain a little bit on control plane, data plane in SDA and management plane.
Later, we'll talk about it when we come to the SDA point. We'll talk about it. But the point is that there are no three different controllers for the control plane, for the management plane, for the data plane. There's no such thing like three different controllers are not there in the DNS Center. You don't need to deal with three different controllers. Unlike you are dealing it in SD-WAN solution, there is no such thing in the SDA. How the control plane is there in the SDA, how the management plane, how the data plane is there, we'll talk about it. Understand that there is just one controller in the Cisco SDA that is responsible to manage all the devices from a centralized point. You can do the you can provision the configuration, you can do the assurance, you can do a lot of things on the devices from a centralized point. But are we going to run OSPF or any protocol with a centralized controller? vSmart? No, there's no such thing. If you have studied SD-WAN, you know that there is a controller called vSmart, and all these WAN devices, they run a protocol called OMP with the vSmart controller. They exchange the route via OMP to the vSmart, and then vSmart advertises it to everyone via OMP. There's no such thing in the SDA. That's what I'm trying to say. Ask the question. Let me see if I can understand.
Okay. As this control plane is not distributed, and we have the option to directly local to the switch and do the configuration.
Okay.
In this SDA environment, these commands and all is same as we usually work on the switches, or
correct. Like for example, if you want to configure the OSPF or anything, the commands will remain same. That is not the true purpose. That is not the true objective of the SDA, to be honest. The SDA allows you to build something called a fabric. It allows you to build something called tunnels that you will use to send and receive the data. But when it comes to configuring the switches, that thing, maybe you can do it with the help of, you can make the reachability with the help of OSPF, EIGRP, and those are like same OSPF, same EIGRP as you have studied so far.
So,
what do you mean by use STP?
Yeah, I will come to that. Point.
What do you mean by fabric? Is it virtualization, right?
Yes, it is overlay tunnels. Now we will talk about like how the SDA solution will fix these challenges that we just talked about, like deployment, this, that, all those challenges. We'll talk about it. But just to revise, we have three things in total. If you want to implement the software-defined networking in your production environment, we have software-defined WAN, which is managing all the WAN edge devices from a centralized point. In order to manage all the WAN edge devices from a centralized point, we have this SD-WAN solution. Cisco offers two SD-WAN solutions, Viptela SD-WAN and Meraki-based SD-WAN. Then, in order to manage the enterprise campus area network, the SD-LAN, SD-Access, we call it. SDA, software-defined access, is the software-defined approach to manage the campus local area network, basically switches, access point, APs, and all that. Software-defined approach to manage the data center, ACI, EPIC. In order to implement end-to-end SDN, you need to deploy these three things. There is no centralized controller for all the three things. There are three different controllers: EPIC, DNS Center, and again, in the SD-WAN, we have vSmart, vManage, vPod. Would have been much better if there was just a single controller to manage all the things, but then how they will sell the solution? So there are three different things. And also, you must understand that the SD-WAN solution is different than SDA solution. The way SD-WAN works is different than the way SDA works. One of the major difference between the two is in the centralized control plane and management plane functionality. There is no dedicated controller for centralized control plane functions as we have in SD-WAN called vSmart. You have to purchase a controller called DNA Center or Catalyst Center. You have to install it in your data center, headquarter, wherever you can install it. It's basically a server. We'll talk about it later on, that you can purchase. It comes with a DNA Center image preloaded. Then you can just install it. Just like you install your operating system, you can install it. So there's a controller you have to purchase first of all. You have to connect it in your network. You have to configure the IP addresses and all that thing. And you will have to make it reachable with the rest of the network. You have to make the controller, you have to make the DNS Center reachable with the enterprise network, the switches, the access point, the WLC. You have to make it reachable to those devices so that you can manage those switches. You can push, provision, the configuration, assurance, monitoring, do those things from a centralized point. How DNS Center is going to solve those issues that we just talked about? Okay, first of all, deployment related challenges. DNS Center, Catalyst Center has features. Features such as PNP. PNP stands for plug and play. It allows you to onboard a device such as a switch, for example, with minimum to no human interaction. Just purchase the switch, unbox it, connect it into the network, and that's it. PNP is part of our content. We will discuss it in quite detail later on. No need to worry about it. Understand that there is a feature called PNP that allows us to deploy a new device in a complete automated way. We can also push, by the way, whatever relevant configuration we want to push in a complete automated way. In few minutes, we can deploy devices with the help of the feature called PM. We have a feature called LAN automation. Let's say that you have that your company, that you're in your enterprise network. Let's say you have to deploy a new site. In that new site, you have to deploy, let's say, for example, 8-10 switches, for example. With the help of the PNP feature, what I can do, I can discover one of the device. I can onboard that device in the Catalyst Center, and then I can use the LAN automation feature to completely automatically discover the rest of the devices, configure them with the IP address, run the protocol, make the reachability, everything. In 5 to 10 minutes, your campus network will be ready. I will show you that practically, part of our content. But with the help of the feature called LAN automation, we can deploy our underlying infrastructure within 5-10 minutes maximum to maximum. No human interaction is needed. No configuration is required. You don't even need to configure the IP address on the switches or make the reachability with the DNS center. Nothing needs to be done. Everything will be done automatically. Everything. With the help of features called PNP, with the help of the features called LAN automation, we can deploy one or more than one device in our campus network in a complete automated way in few minutes, not seconds, of course. 5-10 minutes. If everything is okay, if we have not made any mistake, it will not take more than 5-10 minutes to deploy a new branch, a new new devices in your network.
Sir, do we add a serial number, all this thing?
If you want, you can. If you want, you can pre-provision. If you want, you can pre-provision, pre-install, pre-configure the sequence number and all that thing. But otherwise, what will happen? Anyone will come with their switch, they will connect in your network and they will join your network, right? So if you want, you can pre-approve what devices can join, what devices cannot join. But to be honest, you don't have to do anything. You don't even have to touch the devices. Nothing. Purchase it, unbox it, build the 2-tier, 3-tier, whatever, and just leave it. Make sure that the cables are there, switches are powered on. That's it. We'll do it practically. I will show you practically. Yes.
Is it similar like the Meraki switches where we deploy?
In the Meraki switches, you still need to go to the Meraki dashboard and do the registration.
Sometimes yes, although we can do it through automation like.
No, again, script you have to create, right?
Yes.
We don't need to do that here. You just need to do certain things. You will have to interact with the DNS center, Catalyst center only. You do not need to do anything on the switches. Everything will be provisioned by the DNS center. Everything will be configured by the DNS center automatically.
And if we want some slight changes in that particular configuration, then how to do that?
You can do it while onboarding the devices. You can do that while onboarding the devices with the help of the templates.
Okay.
There is an option to push the configurations, all the whatever relevant configuration you want to push. There is an option called templates. You can push whatever relevant configuration you want to push during the onboarding with the help of the templates, if you want to. Else you can just leave it. Yeah.
Just like we did in SD-WAN with Tila and Versa by using the templates.
Yes, not like those templates, the CLI templates.
Okay, CLI.
Not with the help of the CLI templates.
We have these practical scenarios later on?
Yes.
Hello, sir. What about brownfield?
A brownfield, in case of brownfield, since your infrastructure is already up and running and you don't want to mess up with that, the only thing that you will have to do is to make sure that the reachability is there. Once the reachability is there, then you can you can push the additional configuration from the DNS center itself. PNP or LAN automation feature will not help you.
Let's say I don't have console access and out of band access for that device, and do we need to send someone at the site and provide the access? Let's say already
You will have to you will have to make sure that the DNS center and the switch that you want to manage via the DNS center are reachable. How you will make the reachability is now your concern. Like you can add the routes or whatever you need to do to make the reachability. Anything like make sure some relevant configurations are there on those switches, such as telnet, SSH, SNMP. Some basic things are there, and the switches are reachable with the DNS center in your brownfield deployment. The rest of the things you can do directly from the DNS center there.
Okay, let's say that device is visible in Catalyst Center, and if we push the configuration, then that device will be rebooted, right? I mean, each and every time whenever we push the configuration.
No, there is no such thing. No, there is no such thing.
It is not needed, you mean? It is not mandatory?
There is no such thing actually.
Without boot up, we can, I mean, with the brownfield, we can do the configuration and we can make that device part of our Catalyst Center and we can do the configuration, right?
Correct, but it's not like SD-WAN. You can't just push a template and do the changes on the switches via the DNS center, via the Catalyst center. It's not that straightforward. With like what configuration you are trying to push, what things you are trying to configure on the switches depends, depends on that actually. So if you are planning to configure like OSPF or any these kind of configuration, you will not find like any templates like SD-WAN to push the configuration on the devices. You will have to take some other approach, but it is possible.
So without any downtime, we can make that device part of SDA, and from legacy to SDA, can we migrate without any downtime disruptions?
Yeah, you don't need to reboot. If your devices are already compatible with the compatibility is one thing. If you have already installed a compatible version of the software, the devices are compatible. Yeah, you don't need to do anything like that. The main thing is the fabric. DNS Center is there to build your SDA fabric. We don't use the DNS Center to push configurations like OSPF, EI, GRP, all those things. If you want to do that, you can use the concept of CLI templates. There is an option, but the objective of the DNS Center is to, in fact, create the SDA fabric, push the configuration of the VXLAN, Lisp and all that, set up the rules and all that thing. So if the devices are compatible, it can be done. There is no need to reload the device after the config is pushed.
Okay, thank you, Surinder. Maybe we can discuss in detail while discussing about the migration approach from legacy.
Throughout the content, it will be discussed. Throughout the content, we'll discussing this topic throughout the content. So you don't need to worry about the deployment. You do not need to worry about the deployment using the features such as PNP, using the features such as a LAN automation. You can deploy the devices in a complete automated way with minimum to no human interaction.
Do we need to assign IP via DHCP first?
Nothing. Those things will be done, but we don't need to interact with the switches.
Okay. Got it.
Yeah. Security, we can perform the segmentation. We can create the groups of user not based on VLAN. We are not going to deploy the segmentation based on the VLAN or like ACL. In order to enforce the security, what we can do, we can use this concept called scalable groups.